Good morning, good afternoon, good evening, everyone. Welcome to the week 3 of AWS Cloud Security Bootcamp. Today, we'll take a look at attacks on Lambda and we'll be talking about web-based attack vectors and how we can get hold of initial foothold on a Lambda function and what all we can do once we have compromised the Lambda function. So before we start, any questions so far in the previous sessions? Okay, so before we take a look at the Lambda functions, we'll talk about traditional architecture first and what all issues we have in case of traditional architecture. So whenever we are managing the traditional architecture-based data center, we have to make sure that these servers are running for like 24/7, and we have to make sure these servers are physically secure, they are secure on the software level, and they are secure on the operating system level as well. So now what happens is, for example, if the application is vulnerable and an attacker is able to compromise this server, the attacker can go ahead, perform various kind of attack from these servers to other services and other online servers as well. So to understand this in a better way, let's take a look at a demo. Just a minute. Let me forward this a little. So now let's say you have identified an IP address, and on that specific IP address, you have a web server running. So please note, this is again a demo. You do not have to try this lab. This is a lab on attack defense. So currently the cloud security platform do not have this specific lab. So this is just for demonstration purpose. So let's say you have identified an IP range and you find out that a web server is running on the server. So the first thing we do is again interact with the application to identify what kind of application it is and to find more information about the application. So now most of the times you'll notice that there's a file called phpinfo.php. Now this file is not supposed to be there on the server, and it has to be removed by the developer. But many times developer, they for debugging purposes and accidentally they place this file and leave it there. So this file reveals a lot of information. For example, if we'll go down in here, we'll notice that we have the PHP version information, and below down in here, we'll find out the Ubuntu version information as well. So this file contains information regarding the PHP handler and server configuration, whatnot. Now this also reveals the extensions which are supported on the server. So here we can notice we have an extra xdebug extension. Now, have any of you heard about xdebug extension? Anyone? Xdebug extension is primarily used for debugging purposes. So here we have an xdebug plugin installed. So first of all, what we are going to do is we are going to search if there are any exploits available for this specific plugin. And upon using, again, search, we are using search exploit to identify whether an exploit is available. And here we can notice we have xdebug 2.5.5. Right? So it says that all of the xdebug below 2.5.5 are vulnerable. So we have an OS command injection or OS command execution, and this says Metasploit. So is there someone who has not used Metasploit? Anyone? I hope Metasploit is a very popular tool. Most of you might have used it. So if people have not used Metasploit, it's very easy to use tool. We have to select the module, set the option, and run the command. And it even has very complex exploits, and it makes the task of attacker and pen tester very, very easier to use these exploits. So here again, it says xdebug, which is less than 2.5.5. Now if we'll go back to the application in here, let me go down in here. It says xdebug version is 2.2.3. So this might be vulnerable. So what we are going to do next is we are going to start up Metasploit, and let me forward this a little. And then we are going to search for xdebug. Now, at this point, we are looking for modules corresponding to xdebug, and we are able to find one module. Now, this says the rank is excellent. So all of the Metasploit modules have a rank. So based on these rank, it tells us, how good it is and whether we can expect it to work or not. So in this case, again, the rank is excellent. So it will work most of the times based on, again, if the server is vulnerable. And so now what we are going to do is we are going to use this module. So we just have to mention use followed by the name of the module. And now we have to set the options. So these are the options which we have, and this can be viewed by show options. And here we have the name of the options. And now we need to note the required ones. So all of the ones which are required, we need to set those values. So here we can notice the path is required. Here we can notice the R host is required. So R host is the machine which we are trying to attack, or R host is the victim machine. And here we can notice we have L host in here. L host is the machine where we want to start the listener to get a connection back. So what we are going to do is we are going to enter the R host. We are going to set the R host as the target IP address, and we are going to set the L host to our IP address, which is again the IP address of the attacker machine. So in this case, we have .2, which is the attacker IP address, and we have .3 for the target machine IP address. And then we are going to hit exploit. So now we have successfully exploited the misconfig or vulnerability, and we were able to get a meterpreter session. Meterpreter is again an advanced shell, and it has many commands and utilities built in, which makes the task of pen tester even more easier. Now what we are going to do is, now please note, we were able to get a shell. So this shell, we were able to obtain it due to the xdebug vulnerability, right? So let's say an administrator goes ahead, removes this vulnerability or patches this misconfiguration altogether, right? Now the question arises, at this point, attacker will lose access to this machine. So the next task of attacker would be to make sure that even if this misconfiguration or vulnerability is removed, we need to get hold of this specific target machine. So what we are doing at this point is we are creating a backdoor. So we are going to create a simple PHP script, which is again a simple web shell. So let me explain the script. Let me go back in here. So this is again a very simple PHP web shell. What we are doing at this point is we are checking if CMD parameter is present in the request. And if it is present, we are going to execute this command. We are going to get that value, store it in CMD, and we are then going to execute the passed command with system function. And we are going to return the result. So that's all this script does. It basically fetches whatever data we have sent in the command parameter and executes it with the system command and returns the output. So once we have created this shell, we are going to upload this shell to the web server. So we are going to use the upload shell.php command. And this is again upload and shell.php. This will automatically upload the file into the present working directory, which is the /app directory. Now what we are going to do is we are going to access the shell.php script. And there we go. Now in this case, even if the vulnerability is mitigated, now the attacker has created a backdoor script which the attacker can access later on to execute a command on the server. This again, we can go ahead, execute any command. Now please note this is a simple PHP script. So what the attacker can do is hide this script among many other scripts which already exist on the web server. This way it makes the task of the administrator or the developer very, very hard to find these scripts. So this is again a very simple PHP based backdoor. Yes, the recommended practice would be to edit a web application script itself. So for example, if we have setting.php script which is required by the web application, we can go ahead, change that script and append the web shell code inside that script. So this way it will become even more difficult to find these backdoor script. So now what happens is the attacker goes ahead, creates a backdoor on the Linux server. This way, even if the original vulnerability or the initial vulnerability is mitigated, it still allows the attacker or hacker to get access of the Linux server. Now, this in corporate environment, this is a scenario which you'll find a lot. So generally, web applications are placed behind a firewall, and there are a couple of other machines behind the firewall. And these machines, the attacker cannot access them directly. So this is not possible to do that. So what the attacker can do is go ahead, create a backdoor on these server. And now, please note, this is again web-based traffic, right? So we are accessing everything over port 80 or port 443. And now from this machine, this compromised machine, the attacker can go ahead, perform attacks on these servers. So this makes it possible for the attacker to go ahead, perform lateral movement across the network. Now, the attacker can go ahead, again, once the attacker has created a backdoor on this specific server, the attacker can go ahead, use this backdoor to attack this server, compromise them, and then use these compromised server to perform a planned attack in the later stage. So this is again, many times what attackers do is they compromise a server, they create a backdoor, and then these machines are used to perform planned attacks such as DDoS and other crucial attacks on various servers. Now the question arises, again, is this possible to do on the serverless architecture, or what all attacks we can do in case of serverless architecture, right? So now let's take a look at serverless architecture. So as we already know, in case of serverless, we just have to focus on function code, and everything else is handled by Amazon. It is highly scalable. We only have to pay for the amount the Lambda function executes, or the time taken by the Lambda function to execute, and the memory consumed. Now, let me quickly take you to the Cloud Security Bootcamp portal. So it's going to take a couple of seconds, and this is a URL, right? So this is an API gateway URL, which ultimately triggers a Lambda function. So what I'm going to do is open up inspect element and navigate to the network section. And we are going to take a look at the response time of the API gateway in this case. Just a second, let me fetch another URL. Now here we can notice the response time is 1114 milliseconds. So now let me try to reload the page again, and here we can notice the response time is 216 millisecond, right? So it's around 5 times for the first run, and then it's like the 216 millisecond for the second time. So can anyone tell me why is there a difference in this response time? Anyone? So caching is not the reason. So let me show you for another URL. And for another URL, we'll notice the same thing. The first request, again, in this case, it took almost 3 seconds. And then it was 971 millisecond. So this is because there is a concept of cold start and warm start. So when we are sending the request for the first time, now please note these code, right? Whatever code the Lambda or the developer has written, the Lambda function itself is running inside a container, right? So when we are running the code for the first time, the container has to be brought up. The container has to be prepared. And then this Lambda function or the developer's code is executed on that container. So this process when the Lambda function is executing for the first time, this is commonly referred as cold start. And once the Lambda function is up and running, then consecutive execution will be faster, and it is referred as warm start. So when we have the first request, there's a stage called init or initialization. And here we can notice the first step it performs is creates or unfreezes the execution environment. And once it has created the execution environment, it downloads the code for the function and all of the layers. We'll talk about what exactly layer is in a couple of minutes. And once the code has been downloaded, it initializes all of the extension and initializes the runtime. And initialization here again, when the function initialization happens, it's going ahead configuring the database connections, the initializing the AWS SDK and all of those. So once this initialization happens, the environment itself is ready to execute the function code. So this happens for the first time, and then the invocation of the developer's code happens. Now, once the invocation happens, for example, let me quickly open this one up. So once we are navigating to this specific endpoint, as soon as we get the response from the Lambda function, the execution environment freezes at that point. And then the environment waits for the next invocation. Now, if the next invocation happens, then it goes ahead, invokes the function. And if it does not happen for a limited time, then it goes ahead, shuts down the entire execution environment. And if the time has not exceeded, then it goes back to the waiting state. Now, this time is not fixed, and this has not been revealed in any of the AWS documentation. Sometimes tell it to be 45 minutes, sometimes tell it to be 30 minutes. Now, this is the second request. When the second request is sent, the initialization phase, again, the code, etc., does not have to be downloaded. Only the execution environment unfreezes. And then the invocation happens of, again, the developer's code. And this way, that's the reason why we are noticing significant time difference in case of first request and compared to the second request. So when we're talking about the init phase, there are a couple of initialization which happens. We have extension init, we have runtime init, we have function init. We'll talk about runtime init and function init later on in the session. We won't be touching about extension. Extension is, again, an advanced feature of Lambda. And once the initialization happens, the code is invoked. And if the Lambda function is invoked again, the invoke stage happens again. And this goes on and on and on. And now, when everything is ideal and we have not received any request to trigger an invocation, the Lambda environment shuts down. Now, in case of parallel invocation, so for example, let's say 1,000 users are trying to access the same application at the same time, 1,000 Lambda function will be spinned up on Amazon server. And these, again, will require the initialization. And then for the subsequent request, these will be faster. Now, when we're talking about Lambda execution environment, the beauty about the execution environment is that it's a read-only file system, right? So previously, as an attacker, in case of traditional architecture, the file system was read-only, and that file system was not read-only, and that's why we were able to write the shell.php script, right? So this attack, again, this way of backdooring won't work in case of Lambda execution environment. Now, the memory is based on Lambda configuration, and we have 512 MB of disk space in /temp directory. We'll take a look at how we can abuse this storage later on in the next session. And the important thing to note here is inbound network connection are blocked. So again, this is a containerized environment, so you cannot have an inbound connection to this specific container. You can again reach out to servers from this environment. So again, the outbound connection are allowed. And port 25 SMTP is blocked in case of the Lambda environment. And the maximum execution time is 15 minutes. So we can run the Lambda function for maximum of 15 minutes. Now, this is the traditional, or this is the serverless PHP stack relative to the traditional stack, right? So in this case, we store all of the static files in the S3 bucket, and all of the dynamic content is generated by the Lambda function, and we have the API gateway which triggers that Lambda function, and this goes ahead, talks with the databases to process or get all of the data and then process it and return it back to the user. Now, let me quickly take you to the Lambda dashboard. And this is the function which we had created in the previous session. Now, it's very simple to add an API gateway trigger in here. So what I'm going to do is navigate to add trigger, select API gateway, and select create an API. I'm going to select REST API, and security, we can go ahead, set it to IAM open API key. If we set to IAM, only the IAM user of this specific account can access it. If I set it to open, anyone can access it. So I'm going to select the open option and click on add. Now at this point, we are ready and the API gateway is configured. So we can go ahead, click on the API gateway section, and this is the URL which we have in here. So I'm going to right click on this one, open link in new tab, and it says hello from PA Bootcamps. Now we can go ahead, change the configuration. So let me go in here, and this is the runtime. Just a second. General configuration. Here we can change it to the timeout and the memory from here. So if we try to set this to 30, and it says the maximum timeout is 15. So we have to make sure we set it to 15. It's had to be 0. And now this function can run up to for like 30 seconds, 15 minutes. Now we know that the maximum timeout is 15 minutes, right? So what if I sleep or introduce a sleep of 40 seconds in here? So will this work, anyone? Should this work? Now this is a very important point. Let's wait for a few more seconds and then the API will return us a response. And there we go. And as you can notice, we did not receive a hello message, right? So this says endpoint request timed out. Now, from an attacker's perspective, it is very important to know that API gateway has a maximum timeout limit of 30 seconds. So in case if the Lambda function is taking more than 30 seconds, it won't, again, it will result in a timeout, as we have seen in this case, right? It says endpoint request timed out. So this restriction is imposed by the API gateway. And even if the Lambda function can go up to 15 minutes, this limitation of API gateway is respected, and that's why it returns us an error. So again, this is an important window because when we have obtained a shell on the Lambda function, we'll notice that it is terminating after 30 seconds. So after every 30 seconds, you will have to create a new session on the Lambda function when you are performing reverse shell or based attacks. Now let me take you to the Lambda dashboard. So in case of Lambda function, here we have a couple of Lambda functions. And now whenever we are creating a Lambda function, we have to select a runtime. So we can go ahead, add a custom runtime. When we are creating a custom runtime, we have to adhere to the workflow which Amazon has provided. And once we do that, we can go ahead, use the custom runtime to deploy our own custom functions. So let me quickly take you to, or let me quickly bring up a video. So again, we have to use the credential login to the dashboard, and we are going to navigate to the Lambda section. Now, please note the interface might appear a little different. This is because AWS has recently changed the Lambda interface. So first of all, what we are doing is we are navigating in the application section, and whenever we deploy a function, so let's say if we go to create function, whenever we're deploying an application from here, and this will appear like this. So we have the API gateway endpoint, and then we have the resources mentioned in here. So this is again the API gateway URL of the application, and these are the resources. It has API gateway, and then it has a Lambda function. So now let me go back in here. So whenever we are creating an API gateway, we can add a trigger or integrate it with Lambda function, other AWS services. So whenever it is integrated with Lambda function, we select the Lambda function in here, and then we also mention the region where it resides. Now, this option is used to pass all of the parameters, all of the data which API gateway has received directly to the Lambda function. And this is the Lambda function which we have in this case. Now, in case of deployment, it provides us with the deployment history when it was deployed. And it was, again, most of the time you'll notice that this section, right, whenever we are deploying it, it uses CloudFormation template. So that's why we'll see the CloudFormation stack, and we'll be able to see the stack, and we can go ahead, delete the application by deleting the stack as well. Now, these Lambda functions are monitored with the CloudWatch service. So again, it will provide us with information when was the function last invoked, the frequency, all of those information are present in the monitoring section. Now, layers, we'll talk about layers in a minute. But whenever we are creating a layer, we can associate it with a runtime. So here we can notice we have Node.js 12.x runtime, we have Python 3.8 runtime. So these layers can only be used by the function which are created in this specific runtime. Now these layers can have maximum of 5 versions. So we'll talk about this in just a minute. So let me forward the layers part. And now in case we do not have or we have not mentioned any layer compatible runtime in here, right? So this is again the PHP runtime. So that's why it's not associated with any runtime. Now we are going to go ahead. So this section is changed. So let me quickly go into the Lambda function itself. So if you'll notice, this is again the newer console, and that's why it's slightly different from the video, right? So there will be a slight difference in the interface. So here the important thing to note here is, again, the handler name, right? So this is the name of the file, and this is the name of the function. We have the runtime mentioned in here, and all of the layers will be mentioned in here. So we can go ahead, add a number of layers in here. Now, in case of configuration, so let's go to the configuration section. And here we have the memory limitation as well as the timeout information. We'll talk about layers in just a minute. It will clear up in like next 5 minutes. So now every Lambda function is associated with a role, right? So we can go ahead, change the role from in here. And it's important to note that we have a resource policy which is associated with the Lambda function. So if we'll view the document, this is the resource policy of the Lambda function. So we cannot edit this one directly. So as you can notice, there is no option to edit this one. But here, recently, Amazon has added a feature to add permission to the resource-based policy. So we can go ahead, add the principal, select the action, and add the statement ID. So this, in a way, allows us to add statements to the resource policy. Now, if we'll go to the destinations, we'll talk about destinations in just a minute. Now we can set environment variables in Lambda environment. So we can go ahead, add an environment variable. And this is again the key value pairs. We can directly add this, and it will be available inside the Lambda function. Next, we can go ahead and mention the tags. And we can also run this specific Lambda function inside of VPC. So again, we can edit this one and mention the VPC inside which, or mention the VPC within which this Lambda function should run. And there are a couple of other operation. Monitoring is enabled. Concurrency is again, by default, it is 1000. Asynchronous invocation is again, this Lambda function will retry 2 times in case if this Lambda function is invoked asynchronously. We'll talk about synchronous and asynchronous invocation in just a minute. And this is again the file system. By default, we are only using the temporary file system. We can go ahead, connect a file system, but again, this requires VPC based configuration and a couple of advanced configuration. We won't take a look at additional file system. In this case, we'll take a look at what all we can do with the temporary file system. Now let me go to the US West 2 region. So here I have a data extractor function, right? Now, a beauty about Lambda function is that we can have multiple versions of a Lambda function. So if we'll go to the version section, we'll notice that we have one word, we have version 2. Now, please note, once we create a version, it is immutable. We cannot change it once we have created it. It completely freezes. So if we take a look at the code, and it says code and handler editing is only available on unpublished function page. So we cannot change this one, right? We cannot edit this one and deploy it. So this is again a version of Lambda function. Now, if we'll take a look at the second version, this is a different version, and this is pretty much the same, just like the first version. We can go ahead, test this one out, we can execute it, but we cannot change it. Now we can only change the current version of the Lambda function, which is again when we do not have any 1, 2 mentioned in here, right? So if we'll go to the API gateway data extractor, we'll take a look at the environment variables. Again, everything will become more clear when we are taking a look at an attack on Lambda function. So this is just to explain a couple of properties regarding the Lambda function. So here we can go ahead, for example, in this case, it is referencing to data extractor, right? So this is the latest endpoint. Now, in case if you want to refer to a specific version of the Lambda function, we can go ahead, refer to it like this, :1, right? So we can have :2 in here. So this value colon followed by the number of version, what it will happen is the specific API gateway endpoint will trigger that specific version of the Lambda function. This way we can also have an alias of a Lambda function. We can go ahead, create an alias, and we can refer that alias in here to call that specific Lambda function. So this is again to reiterate, we can only modify the current version, which is again this one. We cannot modify the versions which have been previously created. So 1, 2 has been already created, so we cannot change these ones. So now, important thing to notice, always remember the API gateway limitation, which is the maximum timeout of 30 seconds. So now the question arises, so what if we need to perform an operation which needs more than 30 seconds, right? Because API gateway has enforced maximum limit of 30 seconds, right? So this is where other invocation type comes into the picture. So we have asynchronous invocation, we have stream poll-based invocation. So here what we have is we generate or we trigger an SNS notification, which in turn calls the Lambda function, or we put an object in the S3 bucket, which in turn calls the Lambda function. Now, this can go up to 15 minutes, right? So in this case, the invocation will take up to like 15 minutes for a completion. So whenever we want to perform such an operation, what we do is, again, with API gateway, we trigger another SNS notification, or we put an object in the S3 bucket, which in turn calls a Lambda function. And this Lambda function goes on for like 15 minutes, performs the operation, and then later on we check for the operation status and we get all of the data required, which we required at that time. So then we have the database based triggering of Lambda function. We can go ahead trigger Lambda function based on the changes in DynamoDB table. Now here we have noticed that we have a destination, right? So what we can do is we can configure destination, and this destination could be Lambda function, this could be SNS notifications, and what we can do is we can trigger it like, for example, on success, call this specific Lambda function, or on failure, send a notification using Amazon SNS. So this is possible with this specific section. We can go ahead, on failure, we can select what we want to do, and then we have to select the destination topic and Lambda function and whatnot, right? So we can select this one. We can call this specific Lambda function on failure, on success. So all of this control is available in case of Lambda function. So that's why we have the Lambda destinations. Now, next comes layers, right? So let me go to the dashboard. And here we can notice we have 26 Lambda function, 63.3 MB, 0 out of 75 GB. So this 75 GB is the maximum limit of the storage which is available in Lambda service for a specific region. So now it's important to note that let's say we have multiple Lambda function, and all of these Lambda function use the same code base, right? So this code base can be, it can be in MBs, and if we want to use the same code base again and again in multiple Lambda function, it does not make sense to, again, use the same or replicate the same code base in each of these functions, right? So this is where layers comes into the picture. So layer basically is, again, a shared, or all of the resources which are going to be reused, we store them in form of layers. So this can be libraries, these can be static files, and then we can build out Lambda functions which use these layers. So this way, instead of creating or using the same code again and again, we can reference it through the layer. Now, the advantages of layer is, so let's say you are in an organization and you have a couple of individuals and they are developing Lambda functions, right? Now, many of these developers might need to use libraries which, again, are not used by someone else, and they might end up using vulnerable library, right? So this is just to explain. So let's say we have Alice, we have Bob, and Bob ends up using a vulnerable library. And so this Lambda function is vulnerable, right? So in order to mitigate this in an organization, what we can do is we can create layers, and these layers include all of the libraries which are, again, audited, and someone who is experienced in security can go ahead check that these layers are secure and are good to use, right? So this way we can add or ensure a layer of security when we are writing out these Lambda functions. Because if an individual is using the libraries within this one, the code base is not vulnerable on library level. The vulnerability can only be introduced by this individual in the function or the workflow which he or she has written, right? So this is one advantage of layer. We can go ahead, make sure we have written out secure layers, and then we can ask the developers to use these layers while building out the Lambda function. So this is a question of Raiders. What if someone edited the layer after audit in future? So what we can do is this layer can be, again, inside another account, and we can share this layer with uh, another account. So this way, or we can prevent access of this individual to edit any of these layer and only allow this user to read that layer. So this way, this user won't be able to tamper this layer at all. Can we tag it? So let me go to the layer section now. So here we can notice we have a layer, right? And now each of these layer have 5 versions. So that is the maximum number of version we can have for a layer. We can go ahead, delete a version, and then we can go ahead, create a version. Yes, that is correct. It is like pre-built shared code base. So this again, all of the static contents, libraries, everything is stored in the layer. And this layer is again, when we are building out this layer, we can go ahead, make sure this is safe, and ask the developer to use this layer to ensure a level of security on the Lambda functions. So any other questions in case of layer, anyone? So now 5 version can exist at a time. Now it's important to note that once we have created a layer, we cannot change it, right? So for example, once we have created a version of it, this is immutable. And in order to change the layer, what we'll have to do is we have to delete a version and then create a new version of the layer. So Redis, this I think answers your question, right? What if a user has permission to change the layer? So in case if a version exists, the user will have to delete the version of the layer and create a new version. But now please note that requires a modification to the layers section. And this is again deleting, creating layer. So we can prevent or do not provide the user with that specific permission to prevent any sort of abuse of the layer. Uh, by static content here, I mean binaries. Now, please note static content can be JS, it could be CSS file, right? So these are loaded into the browser, into the client browser. But static content here, I mean binaries, libraries. Now these are executed or are required on the server end. So if we store this in S3 bucket, what will happen is we need to fetch these files on runtime. And as you know, S3 is global storage. And when we are fetching this, it can take additional time. So here, what happens is when we are using layers, this is again a feature of Lambda function. So it again, behind the scenes, it is downloading all of the function code as well as all of the layer. But since this is a feature of Lambda function itself, the operation is very much faster compared to fetching data from S3 service. So any other question? So now if we'll let's take a look at how to use a layer. So as I have mentioned, each layer has a version with it, and this is immutable, right? So we can go ahead, let me select, I think ipcalc. Not sure if this function uses a layer, but yes, okay, this does not use a layer. Let me go back in here. There's so many function, I forgot which one uses, I think this one uses a layer. No. Yeah, here we have the layer. So here we can notice whenever we are adding a layer or whenever we are changing a layer, we have to select a layer. So we can go ahead, select the AWS layer. This is provided by AWS officially. This is the custom layer which we can go ahead and add. And this is a layer which we can mention by uh, mentioning the on. So for example, let's say if you do not want to provide access to an account. So let's say we have an organization account where we have created all of the layer which we want the developers to use. And this is again the developers account. So what we can do is provide the developers the ARN of this specific layer and then ask them to use this specific layer information in here. So this way, the user or the developer would not have any kind of access to the Lambda service which holds this layer, right? Because this is again a separate account. So we can go ahead and mention the ARN in here, or we can go ahead, select the custom layer which we have created. And now whenever we select a layer, we have to make sure to mention the version. We cannot, there is no way to reference the latest version because there is no concept of latest in here. There is, again, version information, and we have to reference the specific version directly. So this is again the layer. And now functions can use multiple layers. And whenever we use a layer, all of the content of these layer are extracted into the /opt directory. And these layers are associated with a runtime. So for example, we can mention that it is associated with Python 3.8 runtime, Node.js runtime, whatnot. And each of these layers, so if we'll go to the layer section again, we'll notice they have a function, or they have a version arn, right? So we can go ahead and reference these layers with the help of arn. Now the layers can be public as well as private. So by default, when we are creating a layer, all of these are private layers. What so this is to answer the question of CS Mukasa, what are examples of AWS layer applicable to Node.js? So let me go to the layer section. So can you please elaborate a little? So here we have one simple example where we have a layer which can be used with the Node.js 12.x runtime. So let me go to the functions and let's go to the serverless image uploader repository. Just a second. This is not the one. Yes, that is correct. It is similar to Docker layer. Yes, we can put it that way. In case of Node.js, we can go ahead have the modules in there, right? So we can place the Node.js modules in there. So let me quickly go to the next slide. And here we can, for example, whenever we are creating a layer, the library dependencies by default for Node.js, this is the path. So for example, let's say we create a layer, and this is a function which references libraries which are present in this layer, right? So in case of Python, what we have to do is we have to make sure this specific directory exists, and inside this directory, we install all of the Python dependency. And in this case, in case of Node.js, we have to create this directory and install the dependencies in this specific directory. And similarly in Ruby, we place the files in here. In case of Java, we place the file in here. Now, in case of binaries, we place the file in bin directory. And in case of libraries, we place it in lib directory. Now, when this layer is extracted in the file system, so please note this layer is extracted in the OPT directory. And then we have the source code of the application in var/tasks, right? So we have the source code of the application in var/task. So let's say now we have packaged the Node.js dependencies in this specific directory, right? So when this is extracted, the Node.js directory will be, or Node.js module will be /opt/Node.js/ and then the remaining path. Similarly, in case of Python, it will be /opt/ this specific path. So now these set of paths are automatically set in the Lambda environment. So the function, Lambda function, will automatically refer to this specific path to look for the libraries. So it checks for this specific path /opt/python lib Python 3.8/site packages. Similarly for Node.js, it will take a look at /opt Node.js/node modules. Yes, that is correct. So let's say we have created a layer slash, or let's say we have created a file called ABC inside the layer. So let's say this is in first layer, or let me explain this way. So let's say we have binary called hello inside a layer named hello. And then we have a binary called world inside the layer world, right? So what we can do is uh, include both of these layer into one Lambda function. And when this is extracted, this will get stacked. So we'll have opt/hello, and then we'll have opt/world. So when this is combined, this two is combined, it will result in opt/hello, as well as, again, in the same directory, we'll also have world file. So that is the meaning of stacked. So whatever file content or data we have inside these layers, they will get packed. And again, uh, whichever layer is X, or whichever layer is included at the last. For example, if we have hello, hello, So this will be again overwritten by the lower layer. So this is again pretty much simple, pretty similar to the stacking which happens in case of container environment. Yes, that is correct. Layers use additional space. So I think the maximum limit or maximum size of a layer can be 250 MB. It cannot exceed that limit. So any other questions? So this is again the Lambda enumeration which we just saw. Uh, the Lambda enumeration using AWS CLI, I'll leave this as a homework to you. And next we are going to take a look at another demo. And before we take a look at command injection on serverless architecture, how many of you are familiar or how many of you have performed command injection attack on traditional web applications? Anyone? Okay, so is there someone who is not familiar with command injection attack? And I'll explain this one real quick. Okay, so let me bring up another video. Just a minute. So this is again a simple command injection on BWOP. So in case of this is the backend code. So I'm going to walk through the simple command injection code. And here we have the backend code which says shell exec nslookup dot target. So here what happens is this specific value, the target value, this is passed by the user. And this is concatenated with the string nslookup space. And please note, in case of PHP environment, shell exec, this function calls sh shell behind the scenes. So for example, when we are inputting a value such as www.nasa.gov semicolon ID, this is passed into the PHP code like this, shell underscore exec nslookup www.nasa.gov semicolon ID. Now this in turn is passed to the Linux shell, which is sh, right? And now we know that this specific command, whenever we have a semicolon in a Linux command, it is broken down into two forms, right? So here, this is the first part and this is the second part. So can anyone tell me what does semicolon do in Linux? I'm not sure if I have asked this before, but what does semicolon do in Linux? So will semicolon depend on the exit code of this specific command? Yes, that is correct. So it is important to note that whenever we are using semicolon, it does not care whether this command has executed successfully or not. It is going to treat these two commands. So whatever we have, this string, both of them will be treated as a independent command and it will be executed no matter what. So in case if we wanted to wait or if we wanted to make sure that this command succeeds, we have to go ahead use ampersand instead of semicolon. This will make sure that this command succeeds and only then this command is executed. So by injecting a simple semicolon, we are able to perform command injection on this specific uh, application. So I'm not able to again find the demo. I think I would have shown the demo for this one. Yes, we can go ahead use ampersand so that again, whenever we are using ampersand, it uh, tells that we have to make sure that the previous command has executed successfully and it has the exit code of 0 and only then go ahead execute the next command. So next we are going to take a look at a command injection attack on Lambda environment. So here we have an application which is running on, let me go back in here. So yeah, So here we have an application which is running on Lambda service. So this is the API gateway URL, which in turn calls the Lambda function. So the application seems pretty simple. What we have to do is we have to upload a file, and then it will maybe provide us with a URL to that specific file. So what we are going to do is we are going to drag and drop this specific file onto the application. And it says error uploading hello world.rtf, max upload size is 4 MB. Now, whenever we are performing command injection and all of these attacks, the best way to understand how the request is being sent to the server is to use interceptor such as burp proxy. So what we are going to use is we are going to configure. So I think I have covered. Okay, this was the video. So before we take a look at the command injection one, I was trying to find the video locally, but I have referred it from attack defense. So let me quickly go ahead, play this video real quick. So this is again, like previous time, we had gone ahead, entered the IP address of the application. And we are going to log into the application. So this is a deliberate vulnerable application, BVOP. And what we are going to do is we are going to log into the application, navigate to the command injection vulnerability. And now we can go ahead, enter the value in here. And if we click on lookup, it does not provide us with any result. But if we'll go ahead, inject semicolon followed by a command, then it goes ahead, executes two set of command. So the first command was failing, that's why it did not return us any result. But the second command succeeded, and that's why we got the output. So in this case, we have www data user, right? We can go ahead, execute the ID command, and similarly, we can go ahead, list out the processes which are running. So this is again a very simple demonstration of command injection attack. It was failing because the lab environment, right? So all of the labs on attack defense, they do not have internet access. So when it was trying to again perform NS lookup, it required internet access, and that's why it was failing. So next, what we are doing is, let me go back in here. So this is a very simple application. We are uploading a file to the application, and it says it throws an error. Now, whenever we get any kind of response, whenever we are enumerating the application for the first time, we use a interceptor, and in this case, we are using burp suite as the proxy. So this is again burp suite. So is there someone who has not used burp suite? Anyone? So in case if you have not used burp suite, you can take a look at this video. We have demonstrated how to set up burp suite, and then you can go ahead, try out various operation on burp suite. So if we go back to the video, we go back in here. So here, what I'm doing is I'm clicking on this specific icon, and this is basically a Foxy proxy plugin. So this is used to, again, pass all of the traffic or configure a proxy. And here, let me draw this one out. So here we have the browser, and here we have the burp suite, and this is the AWS service, right? So by default, the requests are going through directly from the browser to the AWS service. Now what we are doing is we are going to configure a proxy. This is again burp suite, and we are using Foxy proxy to do this configuration, which is tell the browser to send the traffic to this specific tool. And this is again listing on 127.0.0.1 colon 8000 colon 8000. So this is again the port on which the tool is listening, and whenever we will send a request, it will intercepted by the burp suite tool, and it will provide us with the original request which is being sent to the server. So now what we are going to do is we are going to perform the same operation, which is upload the file. And now we get the request intercepted in the burp suite, right? So can anyone tell me what is the first thing which you will do in this case? Or can anyone point out a crucial thing in the response? Anyone? So if you'll notice, we were uploading the file named helloworld.rtf, right? So at this point, an attacker or the user controlled input is actually being sent to the API, right? So again, this is the major mistake in here. A user controlled input is being sent to the application. So at this point, we know that, okay, what if we tamper with the file name? Can it result in anything? So that's what we are going to do. So we are going to send the request to repeater. Now repeater is a feature of Burp Suite with which we can send out, or with which we can tamper with the request, send it and get the response back. So this is again very easy to use tool. Now here we can notice this is the user controlled input, right? So what we are going to do is we are going to simply change this specific value and we are going to append semicolon print env, and we are going to click on send. So can anyone tell me what does print env do? What does this specific command do? Yes, that is correct. So what we are doing at this point is we are trying to perform an injection attack. And to be specific, we are trying to perform a command injection attack. So what we have done is we know that a user controlled input is being processed by the application, and we have injected colon print env. Now we know that in case of okay, so I have not established that in case of Lambda functions, the environment variables are actually present in the, or the AWS credentials are actually present in the environment variables. So here, the reason we are dumping out environment variables and we are not performing commands such as id who am I, this is because environment variable contains the temporary access credentials. So here we can notice we have AWS Lambda function version, and these are all the environment variables defined inside the Lambda function. And if we'll scroll down in here, this is where we get the temporary access credentials. We have the access key. And if I'll scroll down, okay, this is where we have the secret access key. And this is again the session token, this entire thing. And this is again a bucket environment variable which we have at this point. Now if we'll take a look at the S3 endpoint, so let me go back in here. So at this point, you have identified the temporary access credentials. You have identified the name of the region, right? So this is again the name of the region, and this is the S3 bucket, right? We have concluded that this is an S3 bucket because of this string dest underscore bucket. So what we are going to do next is again identify the S3 URL format. Now we know that the name of the bucket is known. We know that region name is known. Now we have to formulate the S3 URL. So this is again an easy way to find out the S3 URL, AWS documentation. And this is the S3 URL format. So we have the bucket name followed by S3 dot followed by the region name and then the AWS amazon.com domain. Yeah, sure, we'll take a break after this one. So what we are going to do is we are going to formulate the S3 URL. And followed by S3, followed by the region name. Now, please note, these are all the information we got at this point from the environment variables. And this is the Amazon AWS.com. So now as we can notice, it says access denied. So when we are trying to access this domain directly, we are performing anonymous access. right? Because again, this is direct access through the browser. We have not configured any sort of credential or anything. So at this point, we can conclude that anonymous access is not allowed on this specific S3 bucket. But now we do have the temporary access credentials also mentioned in the environment variables. So what we are going to do next is we are going to export the temporary access credentials and then interact with the S3 bucket using the temporary access credentials. So this is again, we are simply copy pasting the environment variables, which is AWS access key ID, AWS secret access key, and AWS session token. Now there we go. Now what we are going to do is we are going to interact with the same S3 bucket. And we can go ahead, retrieve the flag. Now please note this bucket was not accessible directly to the user, but due to the command injection vulnerability, we were able to export, or we were able to dump out the environment variable, export them, and then act as the role which is associated with the Lambda function. And since that role has access to the S3 bucket, we were able to get the flag. Now, we have identified the flag. Now the question arises, okay, we have a set of credentials, right? These are the access keys which we have at this point, right? So now the question arises, can we do more with this access key? And in order to find that out, we are going to use a tool called Paku, which we have already seen. So what we are going to do next is again, use the Paku tool, and we are going to use the Docker image. So we're going to copy this one out, and we're going to run the Docker container and pass in the temporary access credential to the Paku tool and then perform the enumeration. We'll take a look at SSRF in just a minute, or we'll take a look at SSRF attack today as well. It's one of the crucial attack in case of, again, cloud native application. We'll take a look at how we can abuse SSRF attacks. So this is again a set of credentials. So let me forward this one real quick. So once we have set this, what we are going to do is we are going to use the S3 module to dump out the S3 buckets. So we are going to run the S3 __ download bucket module. And we'll notice that we have found a couple of buckets. Now at this point, Paku threw an error. And Paku ran into an error while trying to download the bucket. So we are going to use a slightly different approach to download all of the files. So now S3 download bucket, this option or this module has a feature to, again, dump out the object name and then use this list with the other option. Again, whatever names we have, we can pass it with the --DL names option and then download those objects. So what we are going to do first of all is we are going to dump out the name of the files. And once we have the name of the files, we are going to use the second option, which is again the DL names feature. So as you can notice, it says 7 total buckets found, 5 buckets with read permission. Now, please note when you are performing this demo, you will find many more buckets. So this is because again, this video is some time ago. It's not the very recent video. Now, in order to take a look at the downloaded file, what we are going to do is we are going to exec into the container. So again, we had started the Docker container. We are going inside the container now with Docker exec. This is the container ID, and this is the command sh. And the files are available in the sessions folder inside the name of the session. This is again the name of the session. And here we have the downloads directory. And then we have the name of the module. And this is the list which contains all of the file name, right? So these are all the files which were there on the S3 bucket. So what we are going to do next is we are going to use the --dl names option, and we are going to pass that file path to this module. So we are going to copy paste the relative path. So we know that currently we were in the /user and the paku directory. So we were in the /user src paku directory. So we only have to provide the path from here, which is again the sessions directory, to this specific file name, right? That's what we want to provide the path to. So once we provide the path to that specific file, it will go ahead, download these files. Now, please note the error was not supposed to be triggered by Paco in the first place, but this is how we went ahead to again bypass the error and download the files. Now, please note at this point, this bucket or this specific Lambda function had access to 7 buckets, right? And 5 of those buckets were readable. Now, in reality, it should have only access to one specific bucket. And it all started with this specific URL, right? Attacker had only this specific URL. Attacker identified that there is a vulnerability. And from that vulnerability, we found the temporary access credentials. And then we use those access credentials to perform other attacks. So this is again a scenario which I had created. So here you can notice attacker will only start with an API gateway, right? Attacker does not have any sort of access to the AWS account prior. So attacker identifies an API gateway URLs, attacks the Lambda function. And now if this Lambda function is vulnerable, for example, in this case, it was command injection vulnerability. So this provided the attacker with the access credentials of the role, right? So now everything is good as long as this role is again following the permission of least privilege. Uh, so in that way, what will happen is the attacker might not be able to perform or steal sensitive information. But if this role is overly permissive and has access to S3 buckets, has access to DynamoDB service, the attacker can go ahead, steal the data from the database from the S3 bucket. Now, this is again a hypothetical scenario which I had created for a CTF. So from the Lambda function, the attacker can go ahead and interact with the S3 bucket, steal the user data from the DynamoDB table. And this S3 bucket can contain scripts such as installation script, it can contain documents, it can contain keys. Now, all of this is sensitive content. It is not supposed to be public, right? So please note this is not publicly accessible, but it was accessible through the Lambda function. So once the attacker gets hold of these script access keys, the attacker can go ahead, assume the privileged IAM user, and then interact with services such as SSM. And this service, again, can have or can allow the attacker to interact with other EC2 instances, which is again, these are the EC2 instances, right? So this is a public subnet, and from here the attacker can go ahead and interact with machines running on the private subnet, which might have again overly permissive privilege, right? So this is again the role associated with these machines could be overly permissive, which can ultimately provide an attacker with admin privileges on the AWS account. So this is again all of the possibility which can happen, and it all starts with this Lambda function, right? A vulnerability, a mistake that a developer made, and the attacker would punish so harshly for that mistake. So this is why it's very, very important for the developers to build out secure Lambda function. And it's not just about writing the code, right? Here we have functions, here we have layers. So all of this has to be secure. Otherwise, it can lead to severe attacks on serverless and cloud environment. So this is again, when people say that serverless is less vulnerable to traditional architecture, no, it is not the case. In some cases, it can even do more harm compared to traditional architecture. because once the attacker gets hold of the admin privileges on the AWS account, the attacker can abuse the account to cost, again, tens of thousands of dollars in minutes. And then the attacker can also use this AWS account to perform various other attacks. So was this an interesting demo on Lambda? Did you enjoy this one? So next, we are going to take a look at other attack. But before that, let's take a 5-minute break, and then we'll come back and resume with the session. Welcome back, everyone. I'll talk about the AWS cross-account enumeration maybe in the next session because again, it will take some time to explain and do the demo for that. So again, I'm running a little late for this session. So I'll take it up in the next session. So now we saw that there were Lambda environment variables, right? So let me quickly show you the official documentation of the environment variables. So now the Lambda environment variables, which we searched for, had this prefix AWS underscore, right? So these are the environment variables which are defined by the AWS Lambda environment. So these are again the runtime environment variables, and these are the reserved environment variables. So all of these AWS regions, so as we can notice, AWS, all of these environment variables are already created by the environment itself. So we have the handler. So this reveals the handler location, right? So for example, the name of the uh, script and the function to call. So this is again, this information is available inside this specific environment variable. And then we have the XAMZN trace ID. So this is used by something called AWS X-ray. This is again for diagnostic purposes. This is another AWS services which is used for advanced diagnosis. We won't be touching upon this one, but this header is used for that purpose. Then we have the AWS region, the Amazon region where the Lambda function resides, the environment variable or the execution environment, which is again, let me go back to the demo and show this one in here. So as we can notice, we have the AWS execution environment set to AWS Lambda underscore Node.js 12x, right? So this reveals the execution environment. So this information is also available in the environment variables. We have the function name, the memory size, function version, initialization type, on demand or provision concurrency. All of this information is available in here. We have access key ID, secret, and AWS session token. So this is why we were looking for the environment variables in the first place. Then we have something called AWS Lambda Runtime API. We'll talk about this in the upcoming session as well as again later today. This is a very important concept which we'll again take a look later on. And then we have the task route. This is again the path where all of the function code resides. And this is the directory where the runtime code resides. We'll talk about custom runtime, AWS runtime API later on today. And TZ is the time zone. And these are the unreserved environment variables. So here we can notice that this is the path, right? So we have node path, Python path, all of this. So let me go down in here. And as you can notice, this is the path which we were talking about, right? So whenever we are creating node modules inside a layer, we have to package it inside this directory. So automatically, the path includes that specific path. So this is why whenever we are referencing to that specific library which resides in the layer, it will automatically fetch that functions from this specific path. Similarly, in case of Python, it is not mentioned in here, but it is again the path which we had seen previously. And here we can notice the path has the opt/bin directory where all of those binaries reside. In opt/lib directory is added in here where all of the libraries in the layer reside. So that's why inside the layers, we create the bin directory and we create the lib directory and then place all of the binaries in the bin directory and lib libraries in the lib directory. And this is automatically extracted in the opt directory. And since this is added in path, all of these files will be again ready to use. This is again explaining why we had to use or store the binary and library and the modules at specific path in the layer, right? So this is that explanation. Apart from this, the most crucial information is this one, the access keys, or the temporary access credentials, the Lambda runtime API. This is always the same. It will be 127.0.0.1:9000. But it is important to note this part. And this again, the execution environment, what kind of environment It is. This is very crucial. Apart from this, there can be other environment variables. So for example, in this case, we identified the presence of dest bucket, right? So this was the first thing that gave away that there's a presence of S3 bucket, which the Lambda function might be using. So we also have to look at other environment variables. So next we are going to take a look at deserialization remote code execution attack. So how many of you are familiar with the concept of serialization? Anyone? Okay, so to explain this in a easier way, let's think of playing a game on a mobile phone, on a laptop, or a desktop, right? So whenever you're playing a game, let's say there's a character, and this character has certain property. This could be health, this could be level, this could be again money, whatnot, right? And after every level, this increases. Or again, as you face monster, your health might decrease and whatnot, right? So let's say you have crossed a level and suddenly your phone crashes, or let's say your desktop runs out of, or the laptop runs out of battery and the entire system shuts down. So at this point, what will happen is this data, which is again, whenever we are playing game, all of this data is in memory, right? And this is not written on disk until we store it or until we save the data. So when a save operation is performed, what happens is the data from the memory is actually written into the disk, right? And now please note this uh, character, which is basically an object, right? It is an object and contains the health level, money, all of these property. So there is no direct way to write this object into the disk. So what we are going to do is we are going to convert this object into a form which can be written into a disk. So what we are going to do is we are going to convert the state of an object into a linear sequence of bytes. And then we are going to store these bytes onto the disk. And when we start the game again, what will happen is this sequence of byte is converted back into the object. And then again, once we have the object, we have the state which you were when you're playing the game, and you can continue forward. So the conversion of that object into a linear sequence of bytes is known as serialization. And the process of conversion of linear sequence of bytes into the object is called deserialization. So again, once we have the byte stream, we can store the data to the file database. We can transfer it across network to another machine. We can send it to another process. We can perform remote procedure calls and whatnot. So the standard format is XML, JSON, YAML, property list. So this is again object, stream of bytes. We store it in file, store it in database, keep it in memory itself. And then conversion of stream of bytes to object is the deserialization process. And how many of you have used pickle Python library? Anyone? So let me quickly close the videos. Okay, so okay, I think most of the people have not used it, but anyways. So let me quickly show you a simple demonstration with a Python pickle library. So again, at this point, what I have done is I have two Cloud Shell environment. One is in the North Virginia region and one is in the Ohio region. So I have two different machines running in two different regions. So I'll wait for a couple of more seconds for the execution environment to be prepared. So let me quickly close the other tabs as well. It's taking longer than expected. So how many of you have performed web application pen testing? So till the time it loads, I'll ask a couple of questions. And uh, have you performed SSRF attack? Okay, so how will you rate SSRF attack? Let's say out of 10, you have to rate SSRF attack. How will you rate that? Okay, that's good. So we'll take a look at later on in the session, SSRF attack on cloud and how what impact it can have. So now at this point, both of the machines are ready. So what I've done is I have created a class in here. So this is again a very simple class called users. It has a initialization method, which is going to set the name property, and it has a print method, which will simply print out the name. So what I'm going to do is start up Python 3. I'm going to copy paste the code so that the class is initialized. And I'm going to do the same in the machine in the North Virginia region. Oops. Just a second. Cat class.py, Python. For some odd reason, it's throwing an error. Oh, okay. I think, yeah, that is, oh, okay. Thanks for letting me know. I thought Python in this case by default used Python 3 environment. Oops, just a second. Let me copy the code from in here. For the newer machine, Python 2.7 is again depreciated, so that's why. And there we go. So now we have both of the class defined in both of the machine. So what I'm going to do is create an object named Bob, and I'm going to, something is wrong with my keyboard. So I'm going to create a very simple object named Bob. And I'm going to use the print method. And there we go. So at this point, we are creating a simple object, and the initialization method automatically sets the property name, which is the which is the name property, and it stores the value which we have passed in here, and the print function simply prints that name. Now the question arises, how do we transfer this specific object, which is again Bob, right? So this is a user object. I want to transfer this object from this machine to this machine. So what I'm going to do is I'm going to use a pickle library, which is again a very popular Python serialization library. Now I'm going to use the pickle.dumps method, and I'm going to pass in the Bob, right? At this point, it creates or it provides me the serialized sequence of bytes. So what I'm going to do is copy this one from one machine. I'm going to the North Virginia region, make sure I import pickle, and we have already defined the class in here. So what I'm going to do is perform deserialization. So I'm going to perform deserialization with the help of loads method. And I'm going to paste in the serialized bytes. And now we have the Bob object in here. So this way I was able to transfer one object from one machine to another machine. Now, there are a couple of features of pickle method which makes it very, very dangerous, or pickle library which makes it very, very dangerous. So we have the dump method, which we have already seen. This is to create the serialized version of the object. Loads method is to deserialize the data stream. And then this is important. This is again what makes this library very, very dangerous. So we have reduce method. Now, many times at this point, we were performing serialization and deserialization, right? And pickle was automatically able to identify how to perform the deserialization. But many times what will happen is pickle might not be able to identify on how to perform the deserialization operation. So this is where the reduce method comes in. So reduce method is called during, again, pickling, and it returns a tuple that defines how the object is to be reconstructed during deserialization. So this method, again, dictates how the object is to be reconstructed. And let me quickly show a demo of this one. So what I'm going to do at this point is, now let's think like this is the attacker machine and this is the server, which again receives or performs the deserialization. So as an attacker, what I'm going to do is I'm going to define a class called CMD. And here, what I'm going to do is I'm going to create a reduce method. Yeah, something is wrong with my keyboard. And I'm going to return a tuple, which is again os.system. I hope everyone has used os.system command, sh and comma. Now what I've done is I've created a very simple CMD object, which has a reduce method. Now I'm going to import os. Oops. For some odd reason, sometimes dual keys are being typed by the keyboard. Anyways, so now what I'm going to do is I'm going to create a CMD object. And here we have the CMD object. I'm going to dump out this object pickle.dumps CMD. And there we go. Now, in this case, what I'm going to do is I have to import OS library. And now please note, this is the server and this is the attacker machine. Now I'm going to deserialize the input which is provided by the attacker on the server. So pickle.loads. Can anyone tell me what happened? So as you can notice, the prompt actually changed, right? So here you can notice the prompt changed from the Python interpreter to the shell. So this is because what the attacker did was he created a simple payload, which is again pickle payload with a reduce method. Now reduce method, it defined that upon deserialization, we have to call os.system and pass the sh command to that os.system call. So this specific payload, this basically tells the server on deserialization, execute the command sh. So this way, an attacker can go ahead, whenever an attacker finds a serialization-based vulnerability, the attacker can go ahead, create such a payload and inject the command in it. And this way, during deserialization, that specific payload will be processed and it will in turn execute the command, which is again passed on by the attacker. So this is why pickle library is one of the most dangerous serialization library. And if you take a look at pickle serialization or pickle library in general, this is official library and it says the pickle module is not secure, only unpickle data you trust, right? And again, it says it is possible to construct malicious pickle data which will execute arbitrary code during unpickling. So many times developers, again, who are not familiar with secure programming, they go ahead, visit forums such as again Stack Overflow. Now these forums provide us with the best way to again write out very useful code snippet, right? But not all of these posts cover the security consequences. This is where things go wrong. Developers are not aware that things can go wrong if you're performing deserialization of untrusted input, right? So again, that's why many of these deserialization and command injection vulnerabilities are introduced. Now let's take a look at a demo on how to perform an attack and abuse the deserialization vulnerability. So in case of pickle library is not available, there could be other form of or other serialization library which is being used. So you'll have to identify that serialization library and find out the payload which you can use for performing the serialization based attack. So first of all, what we are doing is we are going to use buff suite to intercept the request. And here we have cookie, and this seems interesting, right? We have two cookies. So can anyone tell me how will you approach in this case? What is the next step which you're going to take? So we have one field which is again authenticated is equal to false. This again tells us that, okay, if we'll change this to true, we might be able to perform some kind of privileged operation, right? But now the interesting field is this one, data. This appears to be a base 64 encoded data, right? So again, by leveraging this field, we can perform privilege escalation. But by leveraging this field, we might be able to perform remote code execution, right? And this again opens a whole window of opportunity for an attacker. So this again base 64 encoded data. So what we are going to do next is we are going to pass this data to the decoder. So decoder is another feature of Burp Suite where we can go ahead, decode the payload into various kind of, again, supported options. So can you please confirm whether, okay. So I thought there was, okay, is it still lagging? Okay, so, okay, so if something is wrong, please let me know. So I'll try a different network. So now what we are doing is we are decoding the data. And here at this point, we decoded it as base 64. So let me go back in here so that everyone is on the same page. So we send the data to decoder, and here we decoded it as base 64. And here we have something which is again non-readable, right? But some of the text is readable. So this, at this point, it might be a pickled object, but in order to confirm that it is a pickled object, we need to use Python and decode the data and then perform pickle.loads. So we are going to import base64 as well as pickle, and then we are going to perform pickle.loads operation on the base64 decoded data. So we have to base64 decode the data first. So there is no direct way to know unless we perform this pickle.loads operation. So at this point, as an attacker, we are trying this operation. It's trial and error. So if it returns a proper input, we know that this is a, again, this operation succeeded. So this means it is a pickled object. So at this point, we have one more field, which is username is guest and is admin is set to false. So this provides us with another opportunity, which is again, if we change this to true, we might be able to escalate privilege. But now the critical thing here is we know that pickle.loads is being used. That means pickle is being used to perform the deserialization. So at this point, we can confirm that this application is vulnerable to pickle deserialization remote code execution. So what we are going to do is we are going to import the subprocess module, and we are going to create the class, which is again a very simple reduce method with subprocess command. And we are going to use the check output command, and we are going to pass printenv to it. So now what we are doing is we want to execute printenv command on the application. So we are going to generate the serialized data and base64 encode it, because this is how the application expects it, right? It is base64, or it is pickled data, which is then base64 encoded. So on the server end, it is performing base64 decode, and then it is performing the deserialization. And there we go. So now let me quickly show you the source code of the application as well. So it is AP Southeast 1. And here we can notice again, this is the code of the application. So here what we are doing is, again, we're checking for the cookie which starts with authenticated equal to, and we are checking for the cookie which starts with data equal to, and the data which is sent with this specific cookie stored in the data attribute. Now, if data is not null, we are performing pickle.loads operation, right? So this is again the base64 encoded data is decoded, or the deserialization then happens on the base64 decoded data. Now, one of the issues in here is that we are returning, or we are performing the, or we are returning this error information in here, right? So this is again status code is 500, and then we are returning the serialized or the object. So this is again the object is returned in here. So that's why we have the environment variables dumped out in here. So at this point, we can go ahead, process these environment variables. So what we are going to do is we are going to copy this one out, and we are going to use a simple sed command to beautify the output. So we are simply replacing the //n. So as we can notice, all of the environment variables, they are actually separated by this specific string //n. So we are going to replace this string with a new line character using sed. And there we go. Now we have the environment variables. So this was one way of getting hold of the temporary access credentials and all of the environment variables of which are used by the application. Now, the critical thing to note here is the environment variables were dumped out because of this specific section, right? Because an error was being triggered and the object was returned to the user who is triggering the application or triggering the Lambda function. But many times what will happen is this operation is pretty much blind, right? Because, for example, in this case, this is the attacker machine, this is the server. Once the attacker sends a payload to the server, the attacker might not know that the payload has been executed. So in order to know that a payload has been executed, this is a normal approach we take. What we are going to do is we are going to set up an EC2 instance or a machine with a public IP address and then perform a reverse connection. So before that, let me take you to the next slide. So this is again the application source code. We are identifying the data cookie, stating the data cookie into the data, and then we are base64 decoding the data and unpickling the data. So at this point, if you get a non-JSON value, it triggers an error because we are looking for username field inside the non-JSON value, right? At this point, this value contains environment variables, which is again a set of strings, right? It is not a JSON property. So this fails, which ultimately triggers an error, and the non-JSON value, which are the environment variables, had returned at this point. Now this was the payload reduce method print environment variable. This was the class definition. We serialize the Python object, and then we perform base64 encoding. Now, one way to get, now before we take a look at the next part of the demo, we are going to talk about bind shell and reverse shell. So how many of you are familiar with bind shell as well as reverse shell? Okay, so just to be on the same page, I'm going to explain this real quick. So whenever you attack a target machine and whenever you have compromised a target machine, there are two ways with which you can get shell-based access. So in case of bind shell, what happens is we start a listener on the victim machine. So this is again a simple command to start up the bind shell. And please note, port 4444 will be open on the victim machine. Now from the attacker machine, we'll go ahead connect to this specific port, right? So from the attacker, the connection is initiated to this specific port. Now please note, if we have opened a port, this makes it very much, again, visible to the administrator, to people who are managing the server. They will notice that, okay, one port is open, which was not supposed to be open, right? And if any other attacker, so let's say this is one attacker, attacker one, if attacker two is also targeting the server, they will be able to connect to this port and get a session on the machine. And the important thing to note here is this machine should be reachable from the attacker machine directly. So if this machine is behind a NAT, and this is again the private IP address, we cannot reach to this machine, right? Because again, when we are trying to access a private IP address, this will again refer to the network on the attacker machine is connected to. So in case of NAT, we won't be able to directly reach the machine. So this is where reverse shells comes into the picture. So in case of reverse shell, our machine has to be reachable, and this will be running on port 4444 or any other port we can select, and the listener will be running on that port on the attacker machine. And even if the machine is behind NAT, for example, if the attacker machine or the victim machine is behind NAT, the victim machine can connect through this NAT to this attacker machine. So this attacker machine need to have a public IP address. Again, if you are behind the NAT, you won't be able to get a connection back, right? So that's why we need to have a public IP address. And most of the times, attacker can go ahead, create instances, use various cloud service provider to get hold of a public IP address and a machine which is associated with that public IP address. And then what they can do is they can initiate a connection from the victim machine to that machine. So this is again the difference between reverse shell and bind shell. In case of bind shell, the port will be open on this machine, which is the victim machine. In case of reverse shell, the port will be open on the attacker machine. And from the victim, we will be originating the connection. Now, in case of Lambda, if you'll take a look at Lambda, Lambda cannot have inbound connection. So we cannot have bind shell in case of Lambda. We can only have outbound connection. So at Lambda, with Lambda, we can go ahead connect to public machines, which is again the attacker machine. So that's what we are going to do next. Many times in case of applications, you will notice that it is not returning you the correct output, but it is uh, vulnerable to blind attacks. So this could be blind command injection attack, blind deserialization attack. So this is where you'll have to again create the payload and then feed it to the application and wait for a connection on your server. So this is a very simple object. What we have done in here is this is pretty much the same, right? So function definition, the class definition. The important thing to note here is the payload. So this is a reverse shell payload. So we are using os.system, and then we are calling this specific again. This is a reverse shell payload. This is the public IP address of the attacker, and this is the port. Now, please note, in order to solve this lab, you will need, or in order to solve this part of the lab, you will need a EC2 instance or a machine with public IP address. So I had created an instance with this specific IP address, and this port was open on that specific instance. So I'll explain the code in just a minute. So what will happen is when deserialization happens, it won't return any input or it won't return any output on the web application page, but behind the scenes, it will trigger this specific payload. So when this is unpickled, what will happen is it will initiate a connection on this specific IP address on this specific port. So we are going to, again, run the script to get hold of the serialized object. And then we are going to start a listener on port 65532. So this is, again, the server which I'm running this on is this one, right? So this is the IP address of this specific server. So we have started a netcat listener on this specific port, which is mentioned in the payload as well. Now I'm going to execute or going to pass this payload to the web application. And there we go. So now we have successfully received a reverse shell connection. And at this point, we can go ahead, execute any command. So now please note, in case if you're not able to find the environment variable through the interface and the application is vulnerable to blind attacks, this is the approach you'll have to take. Now, at this point, you can go ahead, execute print env command to dump out the environment variables. And similarly, you can go ahead, inspect the Lambda environment. And these are all the users which are pre-created on the Lambda environment. Now, the important thing to note here is the connection will terminate based on the Lambda timeout setting, and it will be a maximum of 30 seconds. So when I was creating the demo, and it was like really early times, so I was wondering why it was terminating, because it had a 15-minute window, right? So again, the Lambda API gateway integration timeout was of 30 seconds. So that's why this was not respected. And this was the reason why it was terminating this soon. So any doubts so far in this demo on how you have to perform blind attacks? NAT cannot be bypassed, but there is one way to do it. There is a service called ngrok. You can go ahead, configure and use that service to, let me show you if I can. So this is, again, you can go ahead, try this one out. It maps the local, or it creates a tunnel using the service. So as you can notice the web interface, and it will map a specific uh, port from the local host. So you can try this one out. I have not used this, but I have heard about this a lot. So this is the explanation for the reverse shell. We are importing the libraries. This is the reduce method. Then we have the Python one-liner reverse shell. And we are importing the libraries. We have socket, subprocess, OS, and we are creating a socket, and we are connecting to the mentioned IP address. So in this case, it will be the attacker's public IP address and the port information in here. Then what we are doing is we are redirecting the standard inputs, standard output, standard error to subprocess. And then in the end, we are calling the bin/sh to, again, tell what command is to be executed. This way, we are able to perform or get a reverse shell on the Lambda environment. So next comes server-side request forgery, right? So can anyone tell me what all we can do with server-side request forgery? So one of the cheap way to run Kali with public IP address, I won't recommend using AWS because it's slightly costlier, but personally, I feel it is one of the easiest way to run Kali on cloud. So you can use AWS. Again, I think it is covered in the free tier as well. So you can spin up a Kali instance on AWS, and for 12 months, I don't think you will incur any charges for that. So you can, again, if I'll cover that in the session, we might not be able to cover everything in 3 hours. So you can go ahead, search it on Google, or you can DM me after the session. I'll provide you the instruction for how to spin up Kali on AWS. It's very easy. We just have to subscribe to the service and select the required AMI. And so next we'll continue with the session. So can anyone tell me what is the worst that can happen with server-side request forgery, or what kind of attacks we can perform through server-side request forgery? So next, let's jump into a demo for server-side request forgery. So in case of cloud environment, so this is again a very simple application. You might not always find opportunity to perform remote code execution with SSRF, but we can go ahead, perform enumeration, interact with other services. Some cases you might be able to, again, perform code execution, but it is not always the case. So I have a very simple application, and let me close this one real quick. So this is a very simple application, and it provides us an option to check website status, right? We can go ahead, enter the URL, and it will tell us the status and preview of the application. So here I have a URL. What I'm going to do is I'm going to go ahead, paste in iplocation.com, and I'm going to click on check. And currently I'm based in India, so this is definitely not my IP address. So this is the, again, it shows us that the location is United States, Virginia. right? This is because this API or the Lambda function resides in the US Eastern region, which is again the North Virginia region. So can anyone tell me what is the next step which you're going to take at this point? At this point, we know that, okay, we can send out request from this specific Lambda function. So what are you going to do at this point? Anyone? So injection is not the right way to go, but let me quickly try the IP address which P1 had suggested. And it says unavailable. So this clearly does not work. So this is again the link local address which is used for metadata service in EC2, but this is not working in this case. So any other tries? What are you going to do next with this one? 127.0.0.1. So let me try that one. And it will show unavailable as well. Any other guesses? This is a really interesting demo, and personally I feel SSRF on cloud has to be rated 10, provided again it is not a blind SSRF. So can anyone tell me, can we read files with SSRF? So let me go back to the slide. So again, this is the URI syntax, right? So in case of URI syntax, we have HTTPS colon, then followed by the authority, path, query, fragment, all of these things, right? So the first part, HTTPS, this is the scheme. So we have LDAPs, similarly, we have mail to, all of these are schemes, right? We have FTP. And if you'll notice, I've been playing the videos in the browser for this entire bootcamp, right? And this is the URL. So if I'll navigate to, again, if I'll remove this one, and if I'll click on this one, we'll notice this refers to the local file system. So this way, we can refer to files using URLs, right? So let me go back to the next slide. So this is again the URL scheme. And if you'll notice, you have already used this in one of the demo. In the past role Lambda demo, you were actually mentioning the file-based path. So what I've done in here is I have created a hello world file in the Cloud Shell environment, and we can refer this file in two ways. One is the relative path, one is the absolute path. So when we are using the relative path, let me quickly exit this one. When we are referring by relative path, you can notice there is no triple slash, right? So whenever we are referring with absolute path, we have to make sure we refer the entire absolute path. And this way we can go ahead, read etc password file. So let me copy this one out and let's place this in here and let's click on check, and there we go. So this way we are able to read etc password file, right? So at this point we have concluded that we can read local files. So what will be our next step? So we can read files. So what are you going to do next? Anyone? So how are we going to read? You're on the right path, no name, but how are we going to read AWS credentials? So let me try the payload which Ashish has provided. Yes, that is correct. So we are going to read proc/environ. So the reason why this does not return any environment variable. So at this point, please note we are taking a look at the content of HC environment file. Now this file is a system-wide environment variable file. Now in case of Lambda environment, these environment variables are set on runtime. And for the same reason, they are not present in the HC environment file. But we know that there is one more place from where we can take a look at the environment variables, and that place is the proc/environ. So if you take a look in here, now we have the entire set of environment variables. Now please note this, the variables are again, as we can notice in here, this is the end of this specific one, right? This is another environment variable. So they are not separated, all of them are concatenated together. So what we can do is we can refer to the environment variables section of Lambda, and then we can form all of the environment variable values from in here. Now this will provide us with the temporary access credentials. So as we can notice, we have AWS session token in here. Similarly, we'll be able to find AWS secret access key as well as the key ID. Using these set of credentials, we can go ahead interact with the role, and using the role we can go ahead interact with other AWS services. So any question in this part? So this is why it is very, very dangerous. Whenever we have SSRF vulnerability on Lambda function, it could reveal the role temporary access credentials, which we can go ahead abuse to perform and interact with other services. So in many cases, what you'll notice is it might not reveal the environment variable. So you'll have to go over and iterate, access other processes to get hold of the environment variables. So any doubts so far? So this is to answer the question of Radium Hacker. I don't see it being justified at SSRF. Don't we pose as an authorized user in SSRF2 server that the requests are executed? So can you please elaborate a little? Not getting at this point. So as this is again, many times you'll notice that we have simple check website status-based websites, right? So it's not required for these applications to be again authenticated in any way. So this is again a very simple, we are forwarding the request. And so P1, can you also explain why 3? Okay, process ID 3. So this is again just an example. Many times you will notice that the self, it might not reveal the environment variables. So in case if it is not revealed, you'll have to iterate over the number of processes 0, 1, 2, 3, 4, 5. So that's why. It is not necessarily 3. Many times you'll notice it is in 6, 7. So it's just a number which you'll have to try out. So you're iterating over various processes to see if the environment variable is there or not. So any other question? AWS /creds file is not available on the Lambda environment. There is no such file on Lambda environment. So that's why we were looking at the environment variables in the first place. Any other questions? Yeah, if it will be great if you can elaborate a little so that I can clear your doubt in a better way. So now once we have an SSRF vulnerability, so this is again considering that it's not just HTTP based URL. This is a very simple application. And if you take a look at the source of the application, let me quickly go to the US East 1 region. It is a pretty straightforward application. And I think SSRF is the name of the function. And at this point, what we are doing is we are fetching the URL, whatever URL the user has passed, and we are simply using the, I think it is URL lib library. We are using the request function of the URL lib library to pass in the URL. And then whatever URL is passed in here, we're sending a request to that specific URL and getting the response. So this is to answer the question of readers. Can you check it on any live website or anything with more functions? So can you please elaborate on this one as well? We can check the status of any live website from here. So for example, if you want to check the status of Facebook, we can do it from here as well. So many times, many of the application which proposes or provides us with this feature, you can try the same payload on those applications because it might be vulnerable to SSRF if they have not enforced such kind of checks, which is again making sure that file and all of these kind of critical URI scheme are not again accepted. So once you have identified, yes, it will be definitely illegal. You're basically attacking or leveraging someone else's infrastructure, right? So please make sure if you are attacking these kind of URLs, you get a permission from the owner or the web application developer. In this one, feel free to attack the labs which we are provided. These are again built for you guys so that you can practice and learn all of these attacks. So now once we have identified an SSRF vulnerability, we can use something called dict scheme, right? And this scheme can be used to interact with databases. So this is again a very powerful operation which can be performed through an SSRF vulnerability. So once we have identified SSRF, it opens up a whole new window of things for attacker to perform. So next we are going to take a look at XXC injection attack. So again, XXC is again XML, extensible markup language. It is used very commonly, for example, in case of docs, HTML, XML. XML is pretty much everywhere. And we have an XML parser. Now the issue happens is then an XML is provided to a server, and this server is again parsing this XML, right? So the server is again directly parsing this XML, and this XML parser is vulnerable or it is misconfigured. So in case if it is misconfigured, then this XML parser will go ahead, uh, process this XML, uh, which can lead to other attacks such as SSRF uh, and blind XXC based attack. Let me quickly clear the screen. So XXC injection attack can lead to again SSRF based attack. We can go ahead, read the files. We can exfiltrate data using blind XXC, and we can also retrieve data from error messages through blind XXC. So this is how a simple XML payload looks like. We have the doc type declaration. So whenever we are defining an entity, so let me mark this one. So whenever we are defining an entity, we need to make sure we include it in the doc type declaration. So we have, again, this is a declaration, which we have opening of the declaration, closing of the declaration, and then we are declaring an entity. So this is again an entity, or to put it in simple words, we can also refer to this as variable. So we are defining an entity or a variable with the name of welcome. And the value which is stored in this variable is this one, hello world, right? And once we have defined an entity, we can refer it with this specific format, ampersand followed by name of the entity followed by semicolon. So now this is the final XML, which is processed by the XML parser, and it will take a look at that. Okay, an entity exists, so it will substitute that value in here. So we'll have data, text, hello world, text close, data close, right? So that is the final XML payload which we have. Now with XML external entity, this is what happens. So whenever we want to refer a data outside of the XML, we need to perform, or we call it as external entity. So in this case, for example, we are defining an entity called password, and now we need to get some data outside of the XML, right? We are getting data outside of the XML. So what we are doing is we are using the keyword system, and then we are referring to the path or the URI. So here you can notice this is pretty much the same URI which we have seen in the previous case, file : / etc / password. This will allow us to read etc password file, and it will read the etc password file, store that information in the password entity, and then we are dumping that information in here. So this way, this payload will be able to read the file and then print out all of those information. So next, let me quickly take you to a video. So now for a couple of labs, we have provided you Kali interface. So you can go ahead, copy the URL from the dashboard and paste it in here. So this is again a very simple application. It says XML parser. We'll provide it with an XML and it will parse the XML. So here we can notice the body is welcome to attack defense lab and it prints that data in here. So now what we are going to do is we are going to simply change the message and we'll notice the message is reflected in here. Now we are going to inject a payload with the external entity mentioned in it. So this is again the doc type declaration, which we need to have in order to define an entity. We are going to define an entity and this is the basic payload which we have, right? So the hello world welcome payload. And then we are going to create the elements of the XML, which is again, data is the root element. Then we have another text element. We are going to close the text element and close the data element as well. If you click on parse, we'll notice that it returns hello world in here. Now what we are going to do is we are going to refer the external entity. So we are going to change this to password and we're going to mention the system keyword and then we are going to mention etc/password in here. So now we were able to find out the etc password file content, right? So now we can go ahead, try to read the etc/environment file and it is empty. So that's why it does not return us any result. And now if we try to read proc/self/environ, it will fail. It says internal server error. So the reason it is failing is because there are null character inside the proc/self/environ file, and these null characters are not supported by the XML parser. So that's why we are getting an error. Just a second. Oh, okay. This is again a PHP based video. Let me quickly take you to the Python based one first. Then we'll take a look at the PHP based one. So the approach is pretty much the same. So here we are creating the simple XXE or simple XML payload and we get the hello world output. We are going to retrieve the file content in here. So this is etc password. Similarly, we'll get the data from, let me go ahead in here. So in this case, I have not included the proc/self/environ one, but in case if you'll try this one, right? So we have two labs. Just a minute. So if we'll try this one, there are two different XXE attack. So we have included one on PHP runtime and we have included one on Python runtime. So if we'll try the proc/self/environ or Python runtime, you'll notice it fails. This is because the proc/self/environ file contains null character which are not accepted by the XML parser, and due to which it triggers an error. Now the difference in case of PHP runtime, can anyone tell me how we are going to get past this restriction of null characters in case of PHP runtime? So this is where we have to go into language specific, and this is Python versus PHP. So if people have tried, yes, that is correct. We are going to encode the data. So now PHP provides a really beautiful feature of PHP filter. Now this is where an attacker can go ahead, leverage this specific feature of PHP to perform or exfiltrate XXE data. So here we can notice this is again a very simple PHP filter, right? We have PHP://filter and it says convert base64 encode. And this is the resource value. So what we are going to do is copy this value from in here, paste it in here. So what we are basically doing in here is we are telling PHP to read the file, which is again file proc/self/environ, then perform base64 encode of this and then return the data. So this way, even though this file has null character, which is again %00, it is encoded and then it is returned to us. So this way the parser does not break, right? XML parser will not break and it will return us the valid base64 encoded string. And now what we are going to do next is copy the string and decode the string. And based on the Lambda environment variables, we are going to format the string to generate the final set of environment variables. So we'll go ahead, format this one, and there we go. So this is again a major difference between Python and PHP runtime, right? So whenever you identify an XXE vulnerability on PHP runtime, you can go ahead, try the filter. Now, please note, there is no direct way for us to identify whether it is PHP based application or Python based application. So you'll have to perform hit and try just to make sure that it is working or not. So are you asking or are you letting me know? So it will be great if you can share the Python payload. I've been trying for a really long time to exploit the XXE vulnerability to dump out the credentials. And there is one feature of C data which we can do. Okay, so it was a question. So in case of Python, there is a feature called C data where you can encode the characters. But again, it did not work. It was not working. It was still throwing an error. I've tried for like a few days and I was not able to succeed in case of Python environment. So this is only possible in case of PHP environment because there is a feature to, again, encode all of the encoded or there's a feature to encode the data. So this is again Python runtime, PHP runtime. Next, we are going to take a look at Lambda alias routing. So you can go ahead, try the lab, try the proc/self/environ1 on Python runtime. You'll find it won't work. And in case if you have used C data based XXE injection, you can try that as well. And if you're able to find a payload which works, please share it with me. I was not able to, again, exploit or get the environment variable through the Python runtime. And if you are able to write out a payload for that, you'll be the first person to write such a payload, because again, that payload does not exist on the internet as of now. So next, we'll take a look at Lambda alias routing. So let me quickly go to now many times what happens is, let's say you have a function which is deployed on the production environment, right? And you add a new feature. So in these cases, what happens is we generally we do not shift the entire traffic from the stable version to the new version, right? We do it slowly. So this is again a common approach people take. 90% of the traffic is again processed by the stable Lambda function, and then the 10% traffic is processed by the new feature or the newer Lambda function, and then we slowly change this proportion till we completely rule out the stable version. So in case of Lambda, what might happen is, let's say a developer has written out a secure Lambda function, and in later version, a vulnerability was introduced, right? So in that case, what we'll have to do is we somehow have to trigger this specific Lambda function to exploit that vulnerability. So let me quickly show the source code of the application. So I think Lambda alias routing is this one. So let me quickly show you the aliases. So whenever we are creating an alias or whenever we have to do such kind of configuration, we need to create an alias of the Lambda function. So I have created a alias named release, and we can go ahead set the weight. So at this point, there are two versions of the Lambda function. We have version 1, we have version 2. So now let's go to version 1 and encode. So let me quickly walk you through the code of the Lambda function. So here it says, again, it is pretty straightforward, just like the SSRF application. What we are doing is we are fetching the URL from the domain, and then we are checking if the URL starts with HTTP or HTTPS, right? So can anyone tell me whether we can include file based, again, whether we can read file from this specific Lambda function? Any? Yes, that is correct. So this check is very much important, right? We are checking if it is HTTP, HTTPS. Now, if we'll take a look at the second version of the function, so I think I can change the version from here, and let's hope this works. And yes, it worked. So if we'll take a look at second version of the function, we'll notice that there is no such check. So there is no such check, right? We are not comparing the URL at all. So this is again, developer, what they might have done is they might have noticed that there was a requirement of other URI schemes such as FTP, right? And instead of adding that check in here, they thought, okay, people might require access to other scheme as well. So why restrict it to this specific scheme? Let's remove it altogether, right? Because again, this is at this point we might think that this is very stupid to do, but this happens a lot in reality. So many people are not aware of the consequences and they write out very stupid code, right? So this is again, this indicates that the second version is vulnerable. So if we go back to the lambda alias routing, and if we take a look at aliases, here we can notice this is how we can go ahead mark the weight, right? So version 2 has weight of 10 and version 1 has weight of 90. This means that 9 out of 10 requests will be processed by the version 1 and 1 request will be processed by the version 2. So now as an attacker, our first task will be to trigger the version 2. So that's what we are going to do next. So let me quickly bring up another video. So I'll forward this a little. I think this will break the XML parser. I have not tried this payload yet, but you can definitely try this out. And it personally, I think it might break the parser. I'll have to try this one out. So this is again, let me forward this one. We have already seen the function as well as the code. So I'll forward this one real quick. And now what we are going to do at this point is, let me also show you the trigger which we have in here. So again, API gateway is configured, and just a second. Let me go back to the video, and I think the URL I have provided in the, yeah, it is provided in the description. So you can copy paste the URL. And now we know that 90% of the time, the first version will be invoked, which is not vulnerable to SSRF. So if we'll try to interact with HTTPS 127.0.0.1, it says the status has failed. Now if we'll try to, so the status is failed for unavailable website. And for available website, we'll notice that the status is success and the output is provided to us. We have status set to success and output is provided to us. Now what we are going to do is we are going to send a request to file-based URLs. This is again bin bash, a simple for loop. We are going to send 20 requests and then we are going to send file-based URL in the request. So here we can notice we are querying proc/self/environ, and this is again a simple for loop, and this echo is just to have a new line, and this is for I in 1 to 20 we are sending this request. Now we know that this specific request will fail for the first version. This is because again HTTP and HTTPS are reinforced on the first version, but for second version this limitation is not there. So it should trigger or it should dump out the environment variable through the second function. So what we are going to do is we are going to execute the script and then wait for the second version to invoke. So here we can notice what happened was the first request itself triggered the second version. And now we have the set of temporary access credentials. We can go ahead and use this set of temporary access credentials to interact with the application. Now this is just beautifying the script. So this is how you can go ahead, trigger and weighted alias Lambda function. So whenever you get a URL, these are the possible combination you have to try. You have to send out bulk request, see how the application behaves, and it might be triggering another version of Lambda function. And if you can again abuse that specific Lambda function, you might be able to get an initial foothold. The only way is to send out bulk request and observe the response. That's the only way. And once you have identified the parameters, you'll have to perform various command injection based payloads to see how the application behaves. So this is to answer the question of no name. Is there any chance we could know somehow what a Lambda function is? So can you please elaborate on this one? Are you, I'm a little confused on this point. So for example, if Lambda function is being used, there is no direct way to identify if it is a Lambda function unless we have the API gateway headers and responses, right? So for example, let me quickly show you the URL itself. So this is a Lambda function, right? So if we take a look at the responses, in the response header, we'll notice that we have the header, which is X Amazon API GWID, right? So this at this point, it reveals that it is probably an API gateway endpoint. So even if the URL is masked, this will reveal the presence of API gateway. But at this point, this could be anything, right? It is not required to be a Lambda function. This could be an application which is running on EC2 instance. So it's very difficult, again, unless you have a vulnerability, it will be difficult to identify exactly that it is a Lambda environment or not. So for example, if you have a command injection based vulnerability, you can execute a command and it will immediately give away whether it's Lambda environment or not, because printenv pretty much reveals the Lambda environment itself. So next we are going to take a look at another interesting demo, which is again retrieving invocation events. Now, in case of Lambda, okay, so let me quickly bring up a video. Now, before that, let's go back to the Southeast 1 region and take a look at the event object. At this point, please note all of the demos which we have covered at in this session, all of them had a URL, right? So these are completely, again, we do not need to have any kind of access onto the organization account or any of the organization account. And again, using these URLs, we can directly attack these in order to get access or maybe exploit a vulnerability and get access to the Lambda function role and use that role credentials to perform various kind of attack. So all of these demo, I don't think we have used any demo which required access to the account. So that's why it is very, very dangerous. And in fact, in the next session, we'll take a look at one of the, personally, I feel it is the best demo of the entire bootcamp and it is the most complicated one. And we'll take a look at why it is so dangerous when developers build out these insecure applications. Cloud has changed things a lot. And in case of attacker, again, it provides a really golden opportunity for attacker to go ahead, compromise a Lambda function and cause damage, a lot of damage. So let me quickly bring up another video. And before that, we'll take a look at the Lambda function in here. Now, we can notice that we have two objects in here, right? One is event object, one is context object. So what I'm going to do is I'm going to use the preprint library, and I'm going to use preprint.preprint to print out the event object. I'm going to deploy this function, and in the API gateway, I know this is the URL, and just a second, in the monitor, I need to go to the CloudWatch logs. Personally, I feel the new interface is slightly slower compared to the older one. I think it will be easier to go to. Just a second. I'm trying to find the link to CloudWatch. Anyways, so now what we are going to do is we want to find out the event data, which is again present inside this object. So that's why I'm going to take you to the CloudWatch service, and we are going to navigate to the log groups, and we are going to select the function, which is in this case bootcamp batch 3. And here we have a request, right? It says again, it's almost 12:10 in India. So this is again the log group which is recently generated. And this is the event object, right? So we have the entire JSON in here. So as we can notice, we have the source IP address. All of this information is mentioned in here. We have the account ID right in here, right? And now if we'll pass a parameter, so let's say I pass a parameter name is equal to Bob. Now, please note I'm nowhere I'm processing the parameter value, right? And if I'll go ahead in here, if I'll let me go to this one, click on resume, and we should notice another log in here. And now we have another log which was created, and here we can notice we have body set to none. And if I'll scroll down in here, somewhere we'll find query string parameters. There we go. So here we have query string parameter name is equal to Bob, right? So the event object, this specific object contains all of the details which are associated with the request. For example, when I'm sending this request, all of this information is packaged in the event object. We have body, we have again the query string parameter, the source IP address. All of this information is in the event object. Now there is one more feature. Let me quickly go to the API gateway section, and this is the API. And we know that this API has to be deployed in a stage, right? There's a called stage variables. So here we can notice every stage has a section called stage variables, and we can go ahead add stage variables in here. So I'm going to mention the secret as secret 123 and click on this one. Now, once we have set the stage variables, we need to go ahead deploy the stage. So I'm going to go to the resources back again, and I'm going to deploy the API into the stage again, just to make sure that the changes are reflected. And now we know that this specific API, which is again the same API, has a stage variables. I'm going to execute it again. And let me go back in here just to make sure that a new log group is not created. Yes, and no new log groups are created. And we'll go down in here. This is again the latest response which we got, which is again 1214, and here we can notice we have the stage variable value, right? So whatever information is passed from the API gateway, such as stage variables, everything is also available in the event object, which is again this object, right? So now many times what might happen is the stage variables might contain sensitive information which might be relevant for pen testing angle. So that's why we somehow need a way to get hold of the event object. So next what we are going to do is we are going to take a look at the retrieving invocation event lab. So now please note, this is again very important for a demo which we are going to see in the next session. So in case if you have any doubt, please let me know and I'll try my best to clear it up. And in case if you have some questions and I have not answered them yet, please also post them in questions for later so I can take them up later on. So we have a URL and it is a very simple application. So this URL provides a very simple interface to, again, perform some network address-based calculation. So here we can notice we have an input field, and whenever we have an input field, what we are going to do is we are going to try various kind of payloads, various kind of injection-based payloads and whatnot. So here we are first of all, what we are doing is we are exploring the functionality of the application, and it pretty much is very simple, easy to use application, and it returns us with a network address information. So next we are going to inject a payload, which is again a command injection payload with semicolon, and then we are going to provide the ID. Now if you notice, it returns us with invalid IP address, right? So now the question arises, okay, is this response returned by the client or whether it is returned by the server? Because many times developers, what they do is they enforce client side restrictions such as, again, regex match, all of those, to make sure the input is properly sanitized. But many times they forget to impose the same restriction on the server end. So what we are going to do is we are going to configure burp suite and intercept the request and take a look at how the request is sent. So we're going to send an authentic request just to make sure that the request is going through. First request is an options request. This is something called pre-flight request. You can ignore this one. We are interested in the post and get request. So this is again a get request. As you can notice, this is generated by Mozilla Firefox itself, push.services.mozilla.com. So we can ignore this one as well. And this is the one we are interested in. This is a post request to /default endpoint. And here we can notice we have an IP address and then we have options. Now, next what we are going to do is we are going to go back into the application. And before that, we are going to send the request to repeater, forward the request, and we're going to go back to the application, explore the application a little more. We are going to unselect the options and see how the application behaves. And this is again the pre-flight request, and then we have the post request. Now, as we can notice from the options, this somewhat appears to be a command, right? This is the input most of the times the Linux utility requires. So this is the first giveaway that this is probably part of a command. So now the question arises, can we inject a semicolon based or ampersand based command injection payload and see how the application behaves? So we are going to inject semicolon followed by ID, and we are going to send the request. And luckily it worked, right? Now this indicates that the restriction was imposed on the client end and it was not imposed on the server end, due to which we'll notice that this is the response we got. So let me go back in here. So we are going to increase the font size just to make sure it is visible to everyone. And this is again the repeater section. And here we can notice that this is the output, right? UID is equal to 993 SBX user. So this output SBX user at this point confirms that it is a Lambda environment. So now we are going to simply remove the, again, the IP address so that we only get the output of the command. So now as you can notice that there is some difference in the output, right? So this is because, again, the beautification, let me go back in here. So as we can notice, there is some discrepancy in the output. So this is because of the beautification performed by Burp Suite. So what we have to do is navigate to the raw section in here. So this is again the raw tab. So by clicking on the raw tab, it will automatically adjust the space and it will actually return the raw data which is returned by the application. The Burp Beautifier was automatically removing the space. So by clicking on the raw tab, we got the raw data. And now we know that this is a Python based Lambda environment, right? Because again, the file name is lambda function.py. Now what we are going to do is we are going to read the file. And now we have the source code of the application. So at this point, as an attacker, we only have access to the application, right? We did not have any information on other endpoints, on whether the application requires a specific token or not. But the source code at this point will reveal that it requires, or it also supports passing a token parameter, right? So query string parameter contains all the parameters. So we can pass a token parameter. And if this token parameter, so as we can notice in the second step, we are matching if the token parameter matches to the secret token which exists inside the stage variables. If it exists, if the token exists and it matches with the stage variable value, then what we are doing is we are, again, this is the header, we are fetching an API key from the stage variables, and then we are sending a request to this specific endpoint, right? So this is again the endpoint, and then we are setting the headers to make sure we pass in the API key, right? So as an attacker, now we have one more endpoint to play with. So can anyone tell me what are the next steps which you will take in this case? So this is again just to revise a couple of API gateway based attacks. Anyone? How will you approach in this case? So now again, you can go ahead, perform verb tampering and various other kinds of API gateway based attack. You can check if IAM user based access is allowed and whatnot. But now let's say this is again a decent API gateway URL and it is not vulnerable to any kind of misconfiguration which we have seen before. And it strictly requires the API key. There is no other alternative. It requires an API key. How are you going to approach in this case? Now, our task as an attacker at this point becomes to identify the secret token or the API key. So how are you going to find the API key or the secret token from stage variables? Anyone? You have command injection vulnerability. So print env will only provide you access to, again, so now let's say in case of environment variables, the role associated with the Lambda function has the least privilege and cannot interact with the API gateway service. So how will you approach then? So as an attacker, you do not have access to the log group, right? Because this specific Lambda function, it only has access to writing the logs. It does not have access to reading the logs or, again, interacting with API gateway or other services. Metadata service is not accessible through this Lambda environment because, again, it is specific to EC2 and it does not exist in this case. So Raiders is correct. We have to interact with, or we have to somehow dump out the environment, or sorry, the event data. Now the question is, how are we going to get hold of event data? We cannot have access to the logs. We cannot interact with API gateway service. So how are we going to do that? Anyone? So commenting AWS, or sorry, the API key part. So please note, this is a read-only file system, right? This file exists on a read-only file system, so you cannot change the file. Any other guesses? Anyone? So that is again the uh, binary echo event. At this point, again, we cannot change the file, right? So there is no way you can change the lambda function.py script. This script cannot be changed. So we cannot echo it, we cannot print it at this point. So next, what we are going to do is we are going to pause on the demo and now take a look at some of the Lambda internal feature. Now, please note this is very, very important. So in case if you have any doubt at any stage, please let me know, because if there is any confusion, you won't be able to understand some part of the next session. So this is again, we are covering the prerequisites for the next session. This session has been primarily a build up towards the next session. So next, we are going to take a look at Lambda runtime. So before we jump into the next part of this video, we are going to take a look at a couple of core concept of Lambda. So now, as we know that Lambda supports running code and using the supported runtime, right? Now the question arises, if we have to use a runtime which is not supported, what do we do? So in that case, what we'll have to do is we have to create a custom runtime. We have to follow the workflow provided by AWS and build out that runtime, and then we can use that runtime with Lambda service. Now, in order to understand everything in a better way, let's took a detour. Let's take a detour and think of a very simple scenario. Now, let's say you are a customer and you go to a takeaway food stall, right? So this can be McDonald's, Burger King, KFC, whatnot, and you want to order a meal. So when you want to order a meal, what you do is you pay the amount and you provide all the instructions to the counter, and then you'll wait for some time and they will provide you the meal. Now, let's assume that meal has three main components. So a meal can conclude or meal can include a burger, it can include French fries, and it can include again the Coke beverage, right? So whenever you're going to a takeaway food stall, there are many internal operations which are happening, right? So let's say this is a customer, you place an order for a meal, and meal includes French fries, Coke, and burger. But now let's assume that the Coke and French flavors of Coke and French fries are not available, and there is only one flavor available for both Coke and French fries. But in case of burger, you can go ahead customize the burger. For example, you can have different kind of layer and whatnot. So when we go to such a takeaway stall, we place the order in the order counter, right? We pay the money, we place the order. And now what happens is the person in the order counter will go ahead, pass all of this order details to the person in charge, right? And now this person in charge, it's the responsibility of this person to make sure the meal is up to the mark. So this person in charge will go ahead, tell her colleagues to again prepare the Coke, prepare the French fries, and prepare the burger. Now, please note in this case, since the French fries and the burger, or sorry, since the French fries and the Coke only have one version, this operation is pretty straightforward, right? So the Coke will be received to the person in charge, and she'll also get the French fries in some time. Now, in case of burger, the person in charge will have to wait for some duration till the burger is prepared, because it's a custom burger, right? There can be numerous number of layers. It could be medium, small, large size, right? So once everything is ready, once the burger is also ready, the person in charge will inspect that everything is okay, that it's as the customer demanded, and this order or this meal is forwarded to the order counter, and then this order is provided to the customer. Now, this is pretty much the same what happens in case of Lambda environment as well. So in here, instead of customer, you are the user. In case of takeaway food stall, it is the Lambda service. So what we are doing is we are triggering a Lambda function, and then we are waiting for a response. So this is how things in here are. So we are triggering the Lambda function, and Lambda service in turn talks with Lambda runtime API. So let's go back in here. Now let's say this person, right, once he gets the order, that order can be provided to this person in charge either by going on foot and handing that order manually, or this person can also put up that order on a machine, and then this person can go ahead, read that order from the machine, right? So in this case, the medium is either the machine or going on foot manually, right? So this uh, again, this medium in this case is the Lambda runtime API, and the person in charge is the runtime. So the person in charge is runtime in here is responsible for a couple of operations. Now these operations are initialization, running the developer's code, and performing the cleanup. So again, think of runtime as person in charge who is responsible for all of these operations, and the medium is the Lambda runtime API. So here, this is again analogous to the burger. The reason I had mentioned customizable burger is because this is something the developer can control, right? Because the layers and what all of these features of the Lambda function can be controlled by the developer, and it's all of the response time is particularly because of this operation. So to put it in simple words, runtime is the person in charge, and it is a bridge between the Lambda runtime API and the function code. So any doubt in this part on how the Lambda runtime acts as a medium between these services? So any doubt so far? Anyone? Okay, okay, that's great. So think of runtime as the person in charge who is responsible for a couple of operation, and the runtime has to make sure that everything works fine, and it gets the request from the Lambda runtime API, and it returns the response to the Lambda runtime API, which in turn provides the data to the Lambda service, which in turn provides it to the user. So now when we're talking about runtime, it all sounds complicated, right? Runtime is again performing all of these operations, but in reality, it is a simple script. So this is again bootstrap.py, right? So this is the runtime, and this is again, this is the script, this is the shell script, which again runs the runtime. So this is a very simple Python script which is responsible for all of these operations. So this is again the Lambda runtime. Lambda runtime is basically a Linux compatible language runtime. There is a file called bootstrap. This is an executable file, and the runtime runs the functions code setup. So when we are telling about, or when we are talking about functions setup code, this is initialization of the SDK, database connection, and all of these operations. It reads the handler name from the environment variables. So if we'll go to the environment variables in here, the handler name is present in this specific environment variable. So it reads that information. It reads the invocation event from the Lambda runtime API. So what the runtime does, gets the data, which is again, uh, if we compare it to the person in charge, it gets that information from the order counter, right, or the machine. So it similarly, the runtime gets that information from the Lambda runtime API, and it passes that event data to the function. So whatever data we get from the runtime API, we pass it to the function, and then we wait for the response. Once we get the response, we post it back to the Lambda runtime API, and then it goes ahead or returns it back to the Lambda service. So now when we are creating Lambda runtime API, we can distribute it as public private layer. Now let's take a look at the tasks which are performed by the runtime. So let me quickly bring up an image. So now there are two major, or we can classify this as two set of tasks. So first is the initialization task. So in the first set of tasks, what we are doing is we are retrieving the setting from the environment variables. Once we have all of the settings, such as, again, let me go back in here. Once we have all of the settings, such as the handler location, the path where the code resides, as well as the Lambda runtime API address, once we have all of this information, we go ahead, initialize the function. And when we are talking about initialization of the function, this is, again, initialization of the SDK, database connection, all of those operations. Now, in case if in any of these operations an error is happened, then we handle the error and we tell the runtime API that an error has happened. Now, since an error happened in the initialization task, the next set of tasks cannot continue, right? So this cannot go ahead. So that's why what will happen is the runtime environment or the entire Lambda execution environment will shut down. But in most of the cases, this will succeed. An error only happens in case if something has gone wrong with the runtime. But as long as the developers have written out or used an official AWS runtime, it won't trigger in this error. Now, let's say if everything goes well, right? So this state succeeds, we'll go to the next part. Now, this is the part where we get an event data. So whenever a Lambda function is triggered, that information is with the Lambda runtime API. So once the Lambda environment is initialized, and which is again this part, what it does, it queries the Lambda runtime API to get the event data. So now please note, this is the event data which we have seen in the CloudWatch logs, right? So this is all the data which we have seen so far. So this is available with the Lambda runtime API. So at this point, the runtime will fetch that information from the Lambda runtime API. It will prepare the tracing headers. Now, please note this is for the X-ray service, which is again for diagnostic purposes. So AWS X-ray is used for diagnostic purposes. So these headers are set for that specific service. So we won't dive into this one. And next, we know that a Lambda function requires the context object, right? So this object. So next, the runtime creates this specific object. Now we have both the event object as well as the context object. Event object was retrieved from the Lambda runtime API, and context object was created at this point. So with these information, we are going to invoke the Lambda function. And then we are going to wait for this Lambda function to return the response. So this is again the Lambda handler. We are going to call that specific Lambda function, wait for the response. And once we get this response, we are going to send this response back to the invocation or the Lambda runtime API. So there are multiple APIs in Lambda runtime API or multiple endpoints in this API, and we are going to send that data to that specific endpoint. And once we send this data to that specific endpoint, at this point, it will go ahead, provide the data to Lambda service, which in turn will provide the data to the user. So once this is done, once the response is returned, next is again making sure we next comes the post execution phase, right? So in post execution phase, we are handling any error which has happened, and then we are performing the cleanup, right? So in case of any kind of error happens, we uh, post the response to the invocation error API, which in turn updates all of the details and tells that an error has happened, and then we go ahead perform the cleanup. So these are the post tasks, right? So any doubts so far in what all tasks are performed by the runtime? Anyone? Now, please note this is very important for the next session. So please let me know in case if there is any doubt in this part. Anyone? Okay, so I hope this part is clear. So these are the Lambda runtime API. So in order to get an invocation event, we have to send a GET request to this specific endpoint /runtime/invocation/next. And this is the final URL. So here we have the value 127.0.0.1:9000. And then this is the fixed date for the version. And this is the endpoint, right? So this is again this part. So this is everything in here. Now, similarly, to post an invocation response, we have to send a post request to this specific endpoint. To post an invocation error, we have to send a response to this specific endpoint. To post an invocation error or initialization error, we have to post a response at this endpoint. So these are again from official AWS documentation. So next we are going to again continue with the lab, and let's see how we can get hold of the event data. So can anyone tell me how are we going to get event data at this point? We have already covered very basics of the Lambda runtime API, right? Lambda handler, can you please elaborate? Lambda handler is again an environment variable which contains the handler information. So this is to answer the question of header. Is there any possibility that the response from an API endpoint, when sent from a Lambda function to the runtime, generates an error? So just to explain this part, what happens is we have the API gateway, right? And this is interacting with the Lambda service, which in turns interact with the runtime API, right? And this runtime API interacts with the runtime. So if an error happens at this point, that response is returned back to the API gateway. So there is no, again, uh, the runtime takes all of the information which is provided to it as an input, and it only returns the response. So that is correct. We have to interact with the, or we have to send a request to the runtime API to get the next invocation, or send a request to next invocation API and get the event data. So that's what we are going to do next. So now we know that from the Lambda environment, we can go ahead, query the runtime API, right? So this is again the code which is already provided. So let me quickly forward this one. So this is how the vulnerability was introduced. We have the, again, the options are concatenated in here, and this is the user passed input. So that's why the vulnerability was introduced. So let me quickly forward this one. We can go ahead, dump out the environment variables, but in this case, it won't provide us with relevant information. So next, what we are doing is, again, interacting with the Lambda runtime API. So this is the API, and this is the path in order to get the next invocation event. Now the AWS Lambda runtime API, this has a fixed value of 127.0.0.0.1. So this is again the value. This is hard-coded value. This is not changed. So we can go ahead and interact with this specific endpoint. So what we are doing is, this is the code, right? And we know that this is sending a request. So basically that's what we have to do. We have to send a request to the runtime API. So what we are going to do is we are going to copy out the code. So this is again the libraries which we need to import. Now please note, since we are referencing to the code which is being used in the application itself, we know that these library already exists in the environment, and there is no need to add or import external libraries. So next what we are going to do is copy these lines. Now this is the easiest way to, again, send out a request, right? We are importing the request and parse module from URL lib, and then we are using the URL open function of the request module, and then we are passing in the parameter. In this case, it's the URL of the runtime API. So now we have to substitute this value with the environment variable value, which is 127.0.0.1 colon 9001. This is the Lambda runtime API, or the port and the IP address on which the Lambda runtime API listens. And this is the next invocation endpoint. Now we have to make sure we use double quotes and then escape these double quotes. So before that, what we are going to do is, please don't let me go back in here. Now we are going to create a Python one-liner code. So in order to do that, we are going to simply replace all of the new line characters with semicolon. So all of the new lines are replaced with semicolon. And then what we are going to do is we are going to replace the double quotes with an escape sequence. So we are escaping all of the double quotes. Now we have a Python one-liner code with escaped double quotes. The reason we have escaped the double quote is because we are going to inject that Python one-liner in this place, right? So the double quotes are used in the JSON property itself. So if we have another double quote inside the payload, it will break the JSON. So that's why we have escaped the double quotes. And next, what we are going to do is we are going to use the Python 3 interpreter with the -c option. Again, -c is to execute the Python code which we have written, which is a single line, or the Python one-liner code. So we are embedding the code which we have written into single quotes. And there we go. So this is again a Python one-liner code to send out request to the runtime API to get the event data. And there we go. Now we have gotten hold of the entire event data. So what we are going to do is copy the JSON out, and we are going to beautify that JSON. And we are going to use JQ to beautify the JSON. And there we go. Now we have the entire event data with us. Now, as we know, event data provides us with a lot of sensitive information. This could be stage variables which should not be revealed to the public, as well as it also provides us the IP address of, again, the attacker, the account ID information, all of this, right? So any doubts so far in this one? How we can go and interact with the runtime API? And yes, that is correct. We can go ahead. We are interacting with the runtime API to get all of the event data. So what happened was, let's say, again, this is the user, right? So this is the attacker at this point. The attacker goes ahead, triggers an API gateway URL, which in turn goes ahead, triggers a Lambda service. And here it interacts with the Lambda runtime API, right? And then we have the runtime. And the function is executed in the runtime. Sorry. Just a second. Oh. Yeah. So now what this runtime does is it interacts with the Lambda runtime API to get all of the event data, right? So at this point, what we are doing is from inside the function, we are querying the runtime API to get the same event data. So as long as this is part of one execution, so unless it returns the response, it is part of one execution, right? So that event data will be the same. So that event data we are able to fetch now from inside the Lambda environment. So any doubt in this part? Anyone? So this is how we can interact with the Lambda, again, the runtime API to get all of the data. So there are a couple of interesting endpoints, right? We have invocation. We'll go down in here. Let me quickly go back in here. Let me quickly search for Lambda runtime. So here we can notice there are a couple of interesting endpoints, right? So we have next invocation, we have invocation response, as well as all of these are endpoints. It's pretty straightforward. It's a very simple API with which we can interact and perform various kinds of attack. So at this point, we have only seen how to fetch the event data. In the next session, we are going to take a look at a couple of more interesting demos. So this is again the lab which we have just seen right now. And just to reiterate, Lambda runtime API acts like a bridge between, again, the Lambda service as well as the function which we have written out. And this is the actual execution environment. We have the Lambda service, we have runtime API, we have logs API, we have extension API. And this is the runtime plus the function, and then we have the extension. Extension is, again, an advanced feature. We won't be touching upon that one, but this is just to understand the actual execution environment. Now, once you are familiar with, again, once you have performed all of the labs which you have covered so far, you are ready to take a look at the serverless capture, the CTF, which we had organized back in November. So this is, again, relatively easy CTF, and it's based on serverless. There are Lambda functions which you need to attack and get the flag. So this CTF also has a solution manual in case if you're not able to solve it, or if you get stuck somewhere, you can also refer to the solution manual. And I'll recommend solving this one out. This will help you in, again, understanding Lambda better. So any doubts so far? That was the last demo. And how was the session today? Did you enjoy it? So this again was a prerequisite. Uh, so if we'll put this session as like this session and the next session as part of a movie, so we are at the interval right now. In the next session, there will be the climax. We'll take a look at a really beautiful demo on how to gain persistence access on Lambda environment. And I'll recommend everyone to go through at least the last section starting from this part, which is again the Lambda runtime API, Lambda runtime. Uh, and this will help you in again clearing some of the concept, and it will definitely be beneficial in the next session. Next session is going to be very informative on the again Lambda runtime environment, and we are going to touch upon some more core concept. So again, I think students, all of the people attendees have rated the fourth session is way too intense on information. So please be prepared for the next session. And I hope everyone enjoyed the session today, and we'll see you next week with more and interesting demos. And till then, take care. Bye bye.